mind in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
All right, what's up, everybody? Bum, bum, bum. Recky's here. What's up, dude? Game of the week. Jeff's on a 10 watch streak. What's up, Jeff? Jeff, what happened to your other account, actually, by the way? I'm curious. Did we ever discuss this? Or, like, we just don't mention that? Shun Nico. What's up, Gladiator? Good to see you, too. Happy Monday. Happy start of the week. Where'd my pen go? What's up, Pineapple? Good to see you too.
My man.
You got your temp test back? How'd it go? I'm still around, but I don't use it. I'm following 2,000 people. Whoa, you have 2,000 people?
Oh no.
And there's a limit on how many you can follow on Twitch? That's hilarious. Not too bad. 88? Nice. Oh, I see, Jeff. Yeah, rather than go through and have to unfollow people, you're like, yeah, let's just start fresh.
That's dope.
I totally understand. Totally understand. Yeah, I remember when I was at TwitchCon, actually, they were talking about that being an issue on, like, you can only follow so many channels. I think there's also a rule in Discord, you can only be a part of so many servers, but I don't know, I think it would be annoying to have, I think the limit's like 500 servers or something. It's huge. Oh, some counting errors with quantum numbers. Quantum numbers are cool. It's like the address of electrons. Modern day address of an electron. Okay, cool. Yeah, welcome everyone. Today's Monday. Awesome. Some news. Let's see. Oh, we're gonna have you guys vote on the next game for Friday. So make sure go to poll of the week. I guess I should like let me rename the title for this. Can I rename a thread? Can I rename a thread? Yeah, there we go. Okay, so I'm gonna say like April 3rd game vote. Okay, that's what I want to name this. But what's up, Bella? Good to see you too.
My man.
Lag reloading. I don't think my stream's okay, right? Yeah, good. We're doing all right. Okay, but yeah. So here in game of the week, make sure you can go vote for what game we should play during recess. Got a couple coming up on here. You think it's you? Is it you or is it me? So yeah, decide on this. Thursday, we will spin the wheel and see which game is going to be a Friday's game. And then we always give out like $10 gift card to whoever participates and does well in it. Nice. Okay. That's all the big news I had. I'm going to wait for Zach to confirm, but I want to say April 16th, we're going to do, he has a cool game called 16. It's like a little trivia game. I'm sure some of you guys have played it actually from our server. But I'm going to be hosting. The first time someone other than Zach has hosted the trivia game, I'm going to be hosting it. And we're going to do a lot of fun giveaways and events around that. So stay tuned. What's up, Femvox? Good to see ya. My teacher tried a new form of assessing, where we can talk for 5 minutes after reading questions without writing anything, and then write the rest of the test normal to simulate collaboration in the workforce. That's very progressive of them. Wow. I actually really like that, actually. That's kind of cool. We can talk for 5 minutes. What do you guys talk about for 5 minutes? I'm curious. Do you guys actually discuss the question? Yeah, you know, it was funny. I was at, where was I? I was at Wii Spa, which is kind of, it's like a Korean spa type thing. They have like a bunch of like sauna rooms and like, you know, hot tubs and stuff, and it's really fun. It's really relaxing. But there's a water cooler that you can go to get water. And I was commenting on how I don't think the concept of like water cooler talk is a thing anymore, you know? With all the remove to remote learning or remote work and everything and hybrid, no one ever like stands around the water cooler and talks anymore. I'm sure they're probably like just like group chats on Microsoft Teams or something, but I was thinking about how that's probably a valuable thing in human development and communication that's being lost. Nice. Yeah, there you go. You all huddled and decided your strats match. That's great. I'm glad your teacher's doing that. That's really cool, actually. How forward-thinking of your teacher. What's up, Laz? Should I give you a PDE question to teach you some PDE or a Fourier transform? I prefer the PDE. Fourier transforms are kind of like, no. I'm kind of over them. I'd like a PDE. Brascals, you want to give me a PDE? I'll do it. Let me fix my camera on TikTok. I look too like pink. I don't like when I look pink. Maybe not auto exposure. Yeah, we can do auto exposure, but there we go. I need to change the temperature. Oh no, I don't need to look orange. Okay, I think that's better. Okay, cool. Here at the start. Yeah, what's up, Broken? Yeah, Breskel's like, I got you. Nice. Okay, cool. All right, so that being said, let's start the stream, help you guys out with some math and science, and here we go. All right, welcome everyone to Actual Education Office Hours. My name is Dr. Gold. It's a live stream that helps you out with math homework, science homework, all sorts of fun stuff. Let's get started on TikTok and YouTube. My video with the Flat Earther debate should be going live soon. I'm curious to see what gets put into it, because we filmed for like 3 hours, but they're distilling it into like a 15-minute or maybe even like a 12-minute video. So I'm very curious to see what gets put in that. At this point, I think any press is good press, so I really don't even care like what happens. But also, why is this one not scheduling? Wait, I definitely have something scheduled. One sec. Oh, did my scheduler broke? Did my scheduler break again? Damn. When that happens. Okay, one sec. Here, let me manage this. Schedule stream. Yes. There we go. Reuse settings. Next. And let's just make it now. There we go. Cool. Give it a second here. It's loading. Bress, explain why wavelets are better than Fourier transforms. Is that like a convolution thing, wavelets? I remember one of the other grad students in my year was using wavelets to do like video analysis, I think is what they were doing. Okay, there we go. Now we can activate that. Now we connect TikTok. Excellent. Okay, we're all good. The first 3 questions are all calculus. Okay, we'll see. Can you start the question? Reki, chill, dude.
Surprise,
Oh, no.
motherfucker.
Can you start the questions, please? Y'all kids have no sense of patience. The attention span. I love Fourier transforms. I will not be included in your propaganda. All intro calc. Okay, let's go see. So again, yeah, the website for submitting questions is actualofficehours.com. Drop your username, put in a screenshot, hit upload, and it'll get put into our queue here, where these are the current questions in the queue. Just get a Subway Surfers gameplay on the left, seriously.
Oh no.
Yeah, would that satisfy people? Okay, let's pick whose question we're gonna work on first. Let's go choose a winner.
Let's go gambling!
It's you, Reki Red. Congrats. Find the slope of the curve. Nice. Cool. Okay, you tell me, Reki Rek. What way are you allowed to do this? Do you have to use the limit definition? Can you use the power rule? Limit as h goes to 0. Ooh, okay, yeah, good. Yeah, the limit version, yeah. Limit version sucks. I hate it.
No.
It's cool. All right, we'll do it. All right, so what the limit version says is, yeah, the limit, so f prime of a, which is the same thing as the slope of f of x at x equals a. What's up, Sports Glory? Is equal to the limit as h approaches 0 of f of a plus h minus f of a all over a is just some constant. A is a number. That's like where you're trying to find the slope of the curve. I mean, this curve here, x squared minus x minus 2. Let me think what that looks like. I mean, we could factor this like right off the bat, right? So x squared minus x minus 2 is the same thing as like x minus 2, x plus 1. Which, so you now know there's a 0 here, right, at 2. There's also a 0 at negative 1. So, I don't know, vertex is probably down here somewhere. And then, because it's positive, it looks something like this, yeah, right? And so if we're asking what the slope of the curve is at x equals a, you're saying, okay, for a specific... Yes, I can definitely help you with variation of parameters. Fatih, if you want to submit a screenshot to that website down there, actualofficehours.com, of what, like a sample variation of parameters question you have, I'll work through it on the stream here. So for instance, this could be like x equals a. And then we would be figuring out like what the slope is there. Yeah, you're very welcome, Fatih. We could also figure out like what the slope is here. That slope should be 0, right? Because that's a minimum. It's a critical point. You'll learn about that later when you get into more advanced calculus. But okay, cool. So, this is what's called the limit definition of a derivative. What's up, Jason? Doing great. Apparently there's a method called USM which combined Euler, trig, and Weierstrass into generalized loop procedures. Ooh, I do not know what that is. Crazy run. Sounds cool, though. Okay, so when I have this, the first thing I always do is I figure out, like, what is f of a plus h? Which is basically plugging in a plus h anywhere there's, like, an x in our equation here. So this would end up being a plus h squared minus a plus h. Make sure you put a parentheses around this because the minus has to hit both things. And then minus 2. And then let's figure out what f of a is. f of a would just be equal to a squared minus a minus 2. And now we can plug this into our limit definition of a derivative. So it's going to be this thing, the f of a plus h. So it's a plus h squared minus a plus h minus 2. And then minus the whole f of a. So we have to subtract this whole thing. So be careful here. People will sometimes be like, oh, cool, so I'll just do like minus a squared minus a minus 2. No. But that's wrong. Because it's minus this whole thing, which means the minus sign has to distribute on everything. So this is really going to be... One way to do this would be take the minus sign here and put like parentheses around this. If you want to be like safe. You know, sometimes this is like the best way to do it. Like the parentheses will keep you from making mistakes. And then just distribute the parentheses later. Do I think related rates is harder than optimization? I think they're probably about the same. I think related rates is probably a little bit harder. How do you draw so neat with the mouse? I have a pen. I have a stylus. Wow, good job, Gladiator. Sacrificing temporary and current, sacrificing present day joys for future success. Car meets are cool. Yeah. Yes, exactly. Yes, and if you go to university and do well, you can bring a cool car to a car meet instead of having to watch everyone else bring cool cars to car meets. All right, so once we get this, if I were to plug in h is equal to 0 into here, we'd have a problem.
Oh, no.
Because we'd be dividing by 0, and dividing by 0 is bad. We don't like that. Okay. So one way to fix that is we should see if algebraically this simplifies to something that will cancel out this h on the bottom. Because notice, whenever they say like take the limit, you can think about plugging in whatever this value is directly for this variable. So if you did that, right, this would be a 0, which is not nice. And then look here, you'd get a squared minus a minus 2 minus a squared minus a minus 2. So it would look like this whole thing is 0 as well. And then you get 0 over 0, which is really bad. When that happens, the switch in your brain that should go off is, all right, I need to just expand and like do some algebra magic on this to make this look a little bit simpler and hopefully pull out an h or factor an h out somehow so that I can cancel it on the bottom. Yeah, John Locke, if you want to know about trig identities, just submit me a screenshot of a question. I know a lot of you guys on TikTok found us, but this is the website. It's called actualofficehours.com. It's right there. Put your username, drag a screenshot of something that's similar to what you're working on, and then it'll get added to the queue here, and then we do like a cool little picker wheel to see whose question we do. Recky's like, I have good news. What's your good news, dude? Recky, what's up? You could do L'Hopital's, right? But if we're doing the limit definition of a derivative, Candle, I don't think they haven't even really learned how to do derivatives yet. Don't show it to stream? Okay. I don't see anything in my DMs. Okay. So let's expand this. So a plus h squared. So this is going to be a squared plus 2ah plus h squared. And then this is going to be minus a minus h. Got to distribute to both. And then minus 2. And then this is going to be minus a squared plus a plus 2. Nice. Oh, check your DMs. Nice. Wait, I can't share this with the stream? This is really dope, dude. What? I would love to tell the stream this is what happened. What? Why can't I share this? You don't know? Okay. Well, congrats. Recky got an acceptance letter to a college. A very nice college, very prestigious college, and it's into honors mechanical engineering, dude. Nice.
Good job.
Congratulations, Recky. I thought you were younger than Shantrix. Isn't Shantrix your older brother? Did he already go to college? Yeah. Shantrix is your younger brother, maybe? I thought Shantrix was older than you. Okay. A squared minus a squared. Shantrix is your younger brother. Do I had this wrong the whole time?
Disqualified. You done messed up, Aaron.
Oh, man. You guys have been in my servers for years. I always thought Shantrix was your older brother. I guess because he came first. He was here first. Yeah, okay. -2, +2. But congrats, Reki. That's really dope, man.
That's dope.
You should, if you don't want to share it with the stream, at least share it with the Discord. I think the Discord would love to see it. That's really cool, man. You should be proud of that. Just got a 77 on my Calc 1 midterm. Not terrible. Not terrible. Could be better. But you're at least passing, haha. I'll give you that. You can share it, it's fine? Okay, I'll share it. I'll share it on Discord. So yeah, make sure to join the Discord. We love. What's up? Why am I racist? Hey man, what's up?
My man.
I don't know why you're racist. Okay, let's simplify. H squared. So plus 2AH minus A. Okay, look at this. The minus A plus A cancels out too. Goodbye. Okay. So we have H squared plus 2AH minus H all over H. And then we're still taking the limit. Oh, you're Storm Gaming. Oh, what's up, Storm Gaming? I remember you. I'm amazed they let you have the username Why Am I Racist? I thought like things censored pretty hard these days. Okay, cool. All right, so then what we're gonna do is we're gonna factor out. Notice how there's an H everywhere here. This is really nice. We love this. I want to change, but it takes 2 months. Yeah. You could always just create a new account like Jeff did. Let's factor an H out. So we're going to factor out H, and then this is going to give us H plus 2A minus 1 all over H. Cancel, cancel. What's up, Alistair? Why did Jeff make a new account? Jeff made a new account because he hit the limit on the amount of people he was following on Twitch. He was following like 200 apparently, or 2,000. So rather than like unfollow people, he just created a new account. What's up, Video Games Wizard? Okay, so here's a cool thing. Now the H is gone on the bottom. So now we're left with this. 2A plus H minus 1. Limit as H goes to 0. Now I can plug in H equals 0 because then this just goes away. And you're left with 2A minus 1. And this is f prime of A, which is also the slope of the function at A. We can check that kind of just using the power rule. So this is something you'll learn later in calculus. So if you have just y is equal to x squared minus x minus 2, to find the slope y prime, you just take whatever the exponent is here, drop it down. So that becomes 2x, and then you drop the power by 1. So this becomes 2x to the 1. This is the same thing as x to the 1, so this is going to become minus 1x to the 0. But x to the 0 is just the same as 1. And also x to the 1 is just the same as x. And then this is just 0. This goes away. So 2x minus 1 looks like the same thing here. 2a minus 1. And you're done. Congrats. I was just done solving geometry question to do with parametric equations. It was a headache. Yeah, parametric equations can be kind of a bitch. Anyways, nice job, Reki. Congrats. Yeah, I'll give you your gift card later today. Maybe when I'm at the gym, I'll do it. Be on the treadmill and be like, oh, I need to buy gift cards for kids. But yes, congrats on getting into college too, man. That's super awesome, and that's a really hard college to get into. By the way, I know in Canada that's super difficult. Especially you got into like the mechanical engineering. I've seen all the jokes about. Have you seen the memes about going into engineering at that college? Nice. This was Reki. Yeah, they're legendary, aren't they? All right, let's see. Dun, dun, dun. And like always, anytime we do one of these questions, they get added to our Discord. So for instance, here you'll see that Reki's question has been put in right here. There's a nice little timestamp that shows where the YouTube recording for this question was. Also what time it started at. So you can always go back and watch it without having to like scroll through everything and like find it. And then we also post a screenshot of what we did. Is there is no A in engineering school? What do you mean engineering school? Yeah. How much do you charge for questions? I don't charge anything. It's all free. This is all free, dude. Completely free. Yeah. You just have to submit your question to the queue. Anyone who did mechanical engineering undergrad, do you know what level of math do you get to? Usually, I would say Calc 3 at least, and maybe differential equations. I don't think you go past differential equations. Oh, because no one can get an A in engineering schools. Oh, that's funny. No, I solve everything. Anything math or science related. You got a chem question, whatever, we do that as well. Again, the website to get those submitted is here. It's actualofficehours.com. There's only 3 questions in the queue right now, so you have a pretty good chance of your question getting picked next if you submit. And then the chance of your question getting picked increases over time. And as well as if you click this upvote button here every 3 minutes, you also get like a bonus. You want to send a DiffyQ question? Do it, Fati, please. Yeah, Bresco says DiffyQ usually, and I think I had 1 or 2 ME majors in my PDE course. Yeah, I don't think PDEs is required for mechanical engineering, but yeah, you will definitely probably do DiffyQ. Nice. Okay, cool. All right, let's do the next question that someone has submitted. Let's go choose a winner.
Let's go gambling!
Lucky Cat, you're lucky! Oh, you have a friend that loves OChem? OChem's kind of like difficult. Alright, I feel like this is kind of a related rates. Yeah, this, or it's maybe, I think it's like, what do they call it? Implicit differentiation, probably. Fascinating. It is implicit diff, right? Yeah. Okay. I'm gonna show you how I do this. Math people like hate me doing this. They get really like upset at me.
Oh no.
They're just like, they get so upset when I do this, but
Chris Brown dancing.
I'm gonna do implicit differentiation my funny way. Okay. So here we go. We got 6xy plus 5x is equal to 30. What I'm going to do is I'm going to take the derivative of all the variables here. So I'm going to treat every variable as something I need to take the derivative of. And then if I took a derivative of that variable, I'm going to write like either dx or dy based on which one I did. D both sides? Yeah, exactly. Yeah, so here's what I do. Okay, so let's look at this for instance. Let's look at the 6xy, right? Again, I'm going to treat x and y both as things that I need to like take derivatives of. And so what I remember from calculus is if I'm taking the derivative of 2 things that are multiplying each other, I need to use the product rule. Okay, we got to use the product rule for this one, all right? And how the product rule works is I take the derivative of the... Let's ignore the 6. Let's just say it's 6 times whatever. And we're just doing the derivative of xy. Because this is just a multiplicative constant. Anything that's multiplying with derivatives, you can just like kind of pull to the side and then multiply it back. So the rule for doing the product rule is I do the derivative of the first thing times the second plus the derivative of the second thing times the first. Right? They say it's like a prime b plus b prime a. So what is the derivative of just x? Oh, well, the derivative of x, right? That's just x to the 1. That's just the same thing as just 1, right? So I would write, oh, well, derivative of the first thing, derivative of x is just 1 times the second, which is going to be y. But then I need to think, wait, what derivative did I take? Oh, I took the derivative of x. So then I'm going to write dx here. Okay. That was the first part of the product rule, right? Derivative of the first thing times the second, and then write d what the derivative thing we did was. Okay, so then I do the derivative of the second thing. Well, the derivative of y is just 1 times the first, that's x, And then, again, what derivative we take? We took dy. Exactly. Yep. Okay, cool. All right, so that's this taken care of. All right, so then we look at this. Derivative of 5x. Oh, well, the derivative of 5x is just 5, right? And then because I took a derivative of x, I'm going to write 5 dx. And then here, we have the derivative of 30. What's the derivative of 30? Well, derivative of 30 is just 0, because that's just a constant. Right? Derivative of constant is just 0. Why does this feel like a differential equation? It feels like a differential equation because you have multiple derivatives happening. Differential equations tend to use like more exponents of derivatives or like higher powers of derivatives, like second derivatives, third derivatives. This is pretty simple because it's just a single derivative and it's also separable. Yes, exactly. Okay, so once you're here, okay, now let's like multiply things through and just make things look nice, right? So I got 6y dx plus 6x dy plus 5 dx is equal to 0. And now this is the part that gets math people really upset. I'm just going to divide both sides by dt because I'm trying to figure out what dx dt is, and then they give me a bunch of other things. So what I'm going to do is I'm going to say, all right, cool. I'm going to just divide everything by dt. So this is going to be over dt. 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 Yeah. So this is just 0. Cool. And then I'm left with, let's like try to group this. Do you see how these are both dx dt's? So I'm gonna group these together. Okay, cool. Third and fifth. All right, nice. Okay. So this would be 6y plus 5 dx dt plus 6x dy dt is equal to 0. Okay? And we're trying to figure out what dx dt is. Okay, so this is like eye on the prize. So let's plug in the other stuff. Well, I know dy dt is equal to 8. Right? So this I know is equal to 8. I also know that y is equal to 4. So I can plug that in. That's going to be 4. So the only other thing that's missing is x here, right? And so what you have to do is you actually have to use the original equation here to figure out what x would be when y is equal to 4. Because they didn't tell you. So here, I'm going to use this one, plug in. And that's going to give me 6x times 4, which is the same thing as 24x, plus 5x is equal to 30. That's kind of messy, actually. I don't like that. So what, 29x is equal to 30? It's gross. Fine. All right, so that tells me that x is equal to 30 over 29. Right? Okay, so then this is now 30 over 29. And now we can just solve for dx dt. So let's see what we get. So 6 times 4, 24 plus 5 is 29. So I have 29 dx dt plus 30 over 29 times 8 is equal to 0. Okay. So then dx dt is equal to, like, move that stuff over. So you're going to get negative 240, because I'm going to do the 8 times 30, over 29. But then there's another 29 we're going to divide over. So that's going to be over 29 squared. Pressicle says, I was ready to defend your method, and then you did that. I'm not going to do it.
Oh, no.
What happened to the 6? Oh, you're right. There was a 6 as well. Thank you. Thank you, Gladiator. There was a 6. There was a 6. Okay, let's multiply 6 as well. This is kind of ugly, though. Yeah. Right? Yeah. I don't like all the 29s and stuff. Maybe it comes out of something nice. Alright, let's pull out a calculator. So negative 240 times 6 divided by 29 Ew, already nasty. Divided by 29. Negative 1.71. Okay. It doesn't come out nicely, yeah. So, we could also check this, right? This is a great thing about AI. We can just take this. Which AI do we want to throw at today? Gemini, Claude, ChatGPT. I'm feeling like I want to go bully Gemini. Let's go bully Gemini. Let's see if they get the same thing. They probably do. Whose water supply are we going to use first? Blah, 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 blah. There you go. Negative 1.712. The same answer we got. So, nice job. 30 over 29 is the messiest fraction I've seen in the entirety of mathematics so far. Oh, there are far worse. Don't worry. But nice. Okay, cool. Yeah. So that's how you do that one. I agree. Some people get really upset at me for doing this, just dividing by dt. I know mathematically it's probably like not the most elegant thing, but it works. And especially for calculus, intro calculus, you can do it. So do it. Mathematically, it's like a cardinal sin.
Oh no.
Yeah. It's like banks hate him. Look how this one cool trick. What's that meme, dude? Like banks hate him meme. I love this meme. Banks hate him. See how he made $10,000 in an afternoon with one simple trick.
Oh no.
Oh man. What's the other way to do it? Okay, yeah. Here's the technically correct way to do this. Yes, derivative. Yeah, the issue they get mad at is we're treating derivatives as like fractions. We're doing like algebraic stuff in terms of like division when they're operators. You can't separate these. It's supposed to be like DDT is what it is. Yeah. Right, yeah. Yeah. How you're supposed to do this is you're supposed to do like DDT of both sides of like 6xy plus 5x and then is equal to DDT of 30. This is the correct way to do it. This is obviously 0. And then this again, it's the same thing. You're doing a power rule. So you're like, okay, this is 6 times x, y, dx, dt. Or, sorry, times just y. Y dx dt plus... Alright, sorry, no. Not 6 equals, sorry. What am I saying? 6 times y dx dt plus x dy dt. And then you say plus 5 dx dt. We get the same answer. It's just... there's a lot of like steps that kind of get done in your head here. Yeah. Yeah, the teacher gets pissed. Yeah, for sure. Yeah. I think this is easier because sometimes it's really difficult to keep track of like the product rule, like which one you've taken the derivative of. And especially if there's like chain rule stuff involved, it starts getting really complicated. So I say you can do this. If your teacher gets mad, I don't know, tell them stay mad or something. It just works. Okay. Cool. Good question, Pineapple, though. I think what you eventually, like, kind of learn is, I mean, say, for instance, you had, like, 3x to the 5th plus like 5y to the 2nd is equal to 2. And if you were to do DDT of this whole thing, this becomes like 15x to the 4th, and then it's dx dt, right? Because you're effectively doing the chain rule here. You're doing d blank dx times dx dt, and then yet also kind of like fractions, this goes away, and so this is the same thing as d blank dt. That's where this comes from. So you're doing the derivative of this with respect to x, which would be 15x to the 4th. But then you need to multiply by what the derivative of x is with respect to t. So that's kind of how it works. But also this like looks like you also kind of do like fraction math stuff. So like I don't know, it's kind of whatever. But okay, cool. Lucky Cat, did I save your thing? Go find it. Pineapple. Holai. Heidi Low, Lodi High. That's another one. Pineapple. All right, cool. 100 stream streak? Whoa. Laz.
Good job.
That's impressive. I think you might be tied for the longest stream streak. Ethan definitely had a 100 stream streak at one point. That's crazy. You watched 100 of my streams straight? Props, dude. What? That's some dedication. Can we put that on your applications for college? That's what we really need to do. These motherfuckers. Okay. Let's see what we got. Fati submitted one. Nice. Why am I racist? Also submitted one. I'm not actually racist, but his username is why am I racist. All right, let's spin and see who the winner is.
Let's go gambling.
What's up, Raj? Gladiator Leos. Congrats. You had a 42.7% chance. Ooh, sketch the graph. I love sketching graphs. Sketchy sketch. Okay. Okay. Wow. So they start talking about derivatives, all sorts of stuff. More than 99% stream attendance and 11 plus Twitch channels. Yeah. That's dedication, man. Yeah, this is probably a Calc 1 question for sure. All right. I'm going to go with the easiest thing, which is always just like, can I just plot a point on this thing, please? If I can plot a point, I'm happy, right? So f of 0 is -4. That tells me right away what the y-intercept is. So I know. So here, let's like make some graphs. Boom, boom. I know that is a point. So I'm happy with that. So let's keep that there. And we did it. Okay, 1 point is done. Excuse me, sorry. All right. F prime is greater than 0. Okay, so that means, let's like translate this into English. This is increasing from -infinity to 2 and 2 to 5. The fact that they separated it, though, makes me think that there's some sort of discontinuity. You know? Like, why didn't they just say from -infinity to 5? They said they specifically put, like, 2 as a breakpoint. So, yeah, there has to be a hole, right? And then they also said it's, okay, so then it's negative, so then it's decreasing. From 5 to infinity. So we could say here, you know, maybe hole. Maybe there's a hole. It's just kind of weird for them to say that. My spidey senses start going off. Okay, but then they say f prime of 2 is equal to 0. And also f prime of 5 is equal to 0. Okay, cool. So these are what we would call like critical points. Right? Critical points are where the first derivative is equal to 0. And I would say like possible mins or maxes, right? Local mins and local maxes. Yeah, f prime of 2 is equal to 0, right? So there's probably a min at x equals 2 or a max at x equals 2, or there's a min or a max at x equals 5. Yeah, the critical points are interesting. Okay. All right, and then we have the second derivative is negative between -infinity to 2 and then 4 to infinity. So this tells me concave down. Right, so first derivatives tell you increasing, decreasing, or, right, local min or max if it's 0. Second derivatives tell you concavity up, concave down. So I'm gonna put like a sad face. That's what I think concave down is, sad face. And alright, that's from negative infinity to 2. And 4 to infinity. And then this tells me concave up. Here, let me like move the graph down. I'm gonna move the graph a little bit down. You gotta come over here. The Calc 1 memories, yes. When life was simpler, right? And then this is concave up. Concave up means happy face.
Oh no.
Like the happy face. Concave up. From 2 to 4. You got the same topic next week? Alright, cool. So let's do it. All right, so increasing from negative infinity to 2. So let's mark some of these x coordinates. They're kind of important, right? Let's see. We have stuff at 2, 4, and 5. Yeah, 2, 4, and 5, right? So 2, something important, 4, and then 1, 2, 3, 4, and then 5. Does the third derivative mean anything? No. No. That's called jerk, technically, in terms of, like, if we do position, velocity, acceleration, the third derivative is jerk. Yeah, you rarely need the third derivative. Peak unemployment. Sorry, I haven't. Okay. Skew. Yes, yeah. It's called the third moment. It definitely has something to do. Yeah. Okay, so increasing from negative infinity to 2. So that means up to this point, right? I need the function to always be going up, per se. And then I also need to be going up from 2 to 5. So interesting. So, like, something weird is allowed to happen here. And I see where that is. Because here, do you see how they say f prime of 2 is equal to 0? So at 2, there has to be a flat point. Oh, okay, cool. And it has to be increasing. This is actually really weird as a function. Okay. Well, first of all, we know it's going to go through this, right? So it has to, like, go through this. And then at 2, it needs to flatten out. And then at 5, it needs to also flatten out. So let's, like, maybe put a flat point here. So that solves this and this. So here, we've solved this. We've solved this. Let's look at the concavity arguments. So, between negative infinity and 2, it needs to be concave down. Okay, so concave down, but increasing. So, again, this is concave down, and it has 2 parts, right? You can have concave down and increasing, or you have concave down and decreasing.
Surprise, motherfucker.
But, because we know it needs to be increasing, we're only going to use these types of curves. Okay? So, from here, I think we kind of want to do this. Here, let me just make this like a little bit nicer. Super weird, because wait. That means okay. And that's from negative infinity to 2, and then also we say from 4 to infinity. Okay. So this needs to be, again, increasing but concave down. Okay, and then that's just increasing from 2 to 5. Okay, but then we don't, and then from 5 to infinity, it's allowed to decrease. So from 5 onwards, it's allowed to decrease. And also, after 4, the concavity is down. So if it's decreasing and it's concave down, that's going to end up looking like this. It's going to, like, kind of go down. Okay. All right, and then let's look at I'm guessing that it's going to be doing something like this. And we can actually look at that by looking at the concavity between 2 and 4. So between 2 and 4, it's concave up. So concave up, again, is a happy face. But it needs to be increasing. So we're not going to use this part of it. We're going to use this part of the concave up. So it's an inflection point, exactly right. So from 2 to 4, I'm going to have it going like concave up. And then I think we said from 4 to infinity, it's concave down. So yes, exactly. This is an inflection point. So this is going to be, let's see, 2, 3, 4. Wait, we need to move this over. 1, 2, 3, 4, 5. Right, there we go. That's what I wanted. 5 is the flat part. So yeah, it's going to do that. So right here at 4, that's when the second derivative changes from being concave up to concave down. You see how you have like both? You have like concave up for this part, sorry, for this half part, and then you have concave down for this part. It is an inflection point, yeah, because the second derivative is changing from positive to negative. Okay, cool. I think that solved everything we needed. Right? Yeah, look, we have our flat parts at 2 and 5. It's increasing from negative infinity to 2, and then it's also increasing from 2 to 5, and then it's decreasing from 5 to infinity. And then looking at the concavity, it's only concave down from negative infinity to 2, so that's why this is sad. And then also from 4 to infinity, it's also sad. And then it's happy, concave up, between 2 and 4. Which is just this part of the concave up. And then, yeah, here's the last thing. We need it to at least go through that point. Exactly. Okay, cool. But why is flat down? Sorry, Pineapple, what were you asking? Sorry, I didn't see that part of chat. Sorry. What were you asking about? Like, why is flat down? The symbol. Oh, are you talking about like this? Like the flat part I put here? Yeah, that was me, because technically when the derivative is 0, let's see if I can draw something that like looks a little nicer. The derivative 0 occurs here, and that's where the like a max or a min would happen, and the derivative there is flat. So technically it's a point, but I like to draw like the flat thing, so I know that that needs to be like either a max or it needs to be a minimum. In reality, the graph is not flat there. Yeah. No flat earth stuff here.
Oh no.
The derivative is flat there, but the function is not flat. The function is technically curved. But I like to put that so that I know that it has to be either a max or a min. I guess what I could have done, like graphing wise, is you could have just graphed these. Well, no, you can't really, because you don't know where these points are. You just know that you have to like see the whole picture of this. I think the order they put it isn't okay. I would plot the point first, and then I would think about like increasing, decreasing. And then when things are increasing, I want to think about like whether if it's, concave down or concave up, right? Because for concave down, the decreasing looks like this. For concave up, the decreasing looks like this. For concave down, the increasing looks like this. And for concave up, the increasing looks like this. Maybe that's kind of a way to think about it. So think about like concavity. You could do... Actually, I know there's a picture for this. There's a really good picture for this. One sec. There you go. This is what I want. Yep. Again, work. Smarter, not harder. Someone's already done the diagram. I don't need to redraw it with my questionable artist skills. There you go. This is kind of the thing you want to talk about. So this is the first derivative. So f prime of x, right? In this case, this is positive. This is negative. And then this is f double prime of x. And then this is negative. And then this is positive. So if the second derivative is positive, but the first derivative is also positive, you draw like curves that look like this. If the first derivative is positive but the second derivative is negative, it goes like this. So notice, right? This function is still increasing. This function is still increasing. The question is, does it increase this way or does it increase this way? And that gets told by what the second derivative is. Same thing here, decreasing, right? You can either decrease like this, which is concave down, negative second derivative, or you can decrease this way, which is a positive second derivative, or you could actually just go straight down, and that would be when the second derivative is 0. That's maybe the only other thing I would have shown. I would have shown like what happens when it's 0. So when it's 0, it's just this. When it's 0 but decreasing, it's this. And then if the first derivative is 0, you just have a flat line. So like the test 7 and 6, if I'm not oh, okay, sorry. So like the test just based on the drawing, yeah. Jason asks me, what did you major in college? Physics. I majored in physics. Are you working an engineering job? I am not. I have a lot of friends that have, though. I work in like tech and education and startups, and I guess I'm technically an influencer. But okay, cool. Good question here, Gladiator. Hope it made sense. It was a fun question.
Well done! Well done!
Market is done. Put screenshot in. Follow it up. Am I going to stream all summer? Yes. We are going to switch the schedule up, though, because I have to teach at UCLA over the summer. So the streams will be a little bit more focused towards that. You're more than welcome to learn alongside. You're more than welcome to, like, ask questions during it. But I have to dedicate more time to teaching E&M physics. It's 6 weeks from the end of June to like the very first week of August. So I'll explain. We'll stream regularly up until probably mid-June, and then we'll take like a week break, and then I'll start teaching that E&M class, but I'll do it here online, so you guys can go watch. And then, so the amount of like homework help streams we have will be primarily focused towards that UCLA class, but I will still have at least like one dedicated day so that anyone who's not UCLA can ask whatever. E&M, yeah. Zach, are you hyped to learn E&M with me this summer? Shout out to Zach. Cool friend, Zach. Yeah. Okay, awesome. All right, yeah, again, if you're watching us on TikTok, you're watching us on YouTube, and you want to submit a question for us to go through, the queue is only 3 questions right now. It's only 3. The way to do that, go to the website, actualofficehours.com, type your username in, drop in a screenshot, and you may get picked as a lucky winner for us to go through your question here on the stream. Hey, man. What are the dates? Yeah, that's a good question. I will announce it. I think it's end of June, like June 24th, up until like August 1st or August 2nd. Pineapple says, I'm going to be in university for mechatronics and math still got me.
Good job.
Mechatronics is cool. What prior knowledge do you need for E&M? Technically, the prerequisite is calculus. I think it's up to Calc 2. But I like to say, you don't need to know that much calculus, and honestly, I could teach you the calculus you need to know, like, on the fly to be able to do E&M, because it's just kind of like some basic integrals. But yeah, you can pick it up. It's not super hard. If you start doing like graduate level E&M, then yeah. There's a lot of things like Stokes' theorem and Green's theorem that you really need like Calc 3 in order to understand. Okay, let's go check the queue. 3 questions. Let's go choose a winner. Who's it gonna be?
Let's go gambling!
It's Breasticles. What do you got for me, Breasticles?
Got PDE.
PDEs.
Aw, dang
Yes,
it.
yes.
Okay, let's do some PDs. I'm excited. I love learning. Zach's happy for the PDs too. You should be stoked to learn Stokes' theorem, but It's a great joke there, Zach. I like that one.
KBL, I didn't rig the wheel. You should have watched yesterday's stream.
Yeah,
Okay,
dude,
if I
he
could
got
rig the
screwed
wheel-
on the wheel. You got screwed on the wheel last time, dude.
Yeah, it was a rough one. It was rough.
I think you waited an hour and a half before you got to your question, and
Yeah,
you submitted
I think it was
first.
like an hour and a half.
And you submitted first too, didn't you?
Yeah, that was a crazy part of it.
Yeah.
I was waiting a long time.
He was waiting patiently, waiting for his time to strike. Okay. Solve the equation 1 plus x squared ux plus uy is equal to 0. Sketch some characteristic curves. Okay, first of all, what is ux? I'm guessing ux is du dx.
No, not. Well, it's the partial of u with respect to x.
That's what this is?
Yeah. We just
Okay.
you write ux when you're doing PDEs because it's like.
Because this is like
shorthand and
normie
easier
shit.
than writing. Yeah, it's easier.
We
than
don't want to do
just
this. Yeah, that sucks.
doing all that.
Yeah, don't do that. Okay. All right, let's see. Okay, and then there's still an x squared in there. And
Yeah,
also
and
there's a
so-
y.
Yeah, so our first step that we want to do is we want to divide by a 1 plus x squared so
Okay.
that it's in the form ux and then 1 over 1 plus x squared uy.
Okay, so let's do that. So this is uy over 1 plus x squared. But then this is still equal to 0, right? I guess we're assuming x... Well, okay, well, there's no way this can be 0 because x squared can't equal -1.
And so what we do now is what's called the method of characteristics.
The method of characteristics.
Yeah, it's a lot of PDE is just simplifying our
Just getting it to
PDE
look like
into an
something that we know
ODE.
how to do.
Well, we're just making it into an ODE. And so
Okay.
what the method of characteristics basically says is that we have what are called characteristic lines, where
Okay.
along that line, it's just an ODE.
Okay.
And we can solve it that way. And so you'll figure out your characteristic lines by taking a look at what's called your total derivative, if you remember that from
Ooh.
Calculus 3.
Like this thing, total derivative? This is a total derivative, right?
No.
Right? Oh, I got it screwed up.
No, so you would say your du ds is equal to ux times dx ds plus
Wait,
uy.
one sec. Du ds is equal to, I'm going to guess, 1 sec, I think I can get this. I think this is partial u, partial s. No, partial u, partial y, partial s, plus partial u, partial x, partial s. Did I do that right?
Yeah, and then technically you have a u partial s, but we don't really worry about
A
that.
u partial s. What?
Oh,
plus,
yeah, well, yeah,
plus partial u, partial s.
yeah, and technically you don't really need to worry about
Wait,
that.
didn't? Okay, I see what you're talking about. Yeah, okay.
And then
Okay, we don't worry about this one.
so you'll get a uy, and then you can change your partial
so-
y, partial s, and your partial x. partial
duds
s
is
to a
equal to
normal
uy, and then I don't know what
And
partial
then-
y, partial s is.
Yeah, but we'll say that's just dy ds.
Okay. And then I'm gonna say
Alright,
plus
and that's-
ux dx ds. Yeah.
Yeah, and that's just our total derivative from Calc 3.
Okay.
Um,
Cool. Total
And
derivative.
then you can take a look at that to figure out your characteristic lines. So we can pick.
Oh, is
S
this also
be
gonna be
any
equal to
variable.
0? Is this all equal to 0 too? Or no? Am I gonna make this like look
yes.
like this?
Kind of. So we'll choose S to be any variable as long as, right, our variable that we pick doesn't equal 0. It's fine. So in this case, we'll choose it to be du dx because we know that our ux equals 1, or not our ux, our dx is 1. So it's fine. We can just pick it to be du dx.
Sorry, so I'm going to choose S to be X. Is that what I'm saying?
Yeah,
Okay.
We're going to do du dx.
We're going to say, okay, let S equal X. So then du dx total is equal to uy dy dx plus ux dx dx. But that's just 1, right?
Disqualified.
Oh, and that does
yes.
look like this.
Yeah.
Okay, cool.
Right. So then we can take a look and we can say, okay, our dy dx is going to be
I see.
1
This looks like this
over
shit.
1 plus x squared.
Wow. Okay, so then this looks like this. Okay, cool. I see. So 1 over 1 plus x squared is equal to dy dx.
And then we have another condition in there. I'm just going to send it in Discord because I don't remember what that symbol is called. I usually just call it squiggly. But it's
is it like one of these things? One of these things in math?
Yeah, pretty much. Yeah, it looks kind of like an epsilon, but it's
like
got
zeta.
like a squiggly or
I think
something.
it's zeta. I think this is zeta. What symbol is this, Zach? What is this? It's like I don't know, paraplegic E or something.
Yeah, something like that.
Yeah. Okay.
Right, and then so it reduces, and we also get a du over dx is equal to 0.
Okay. And then this is equal to 0. Okay, so that, and then du dx is equal to 0. So can I evaluate right now for like what y is? Right, it's arctangent. Yeah.
Yeah, you can evaluate your y.
Let's do it. So we would say 1 over 1 plus x squared dx is equal to dy. Integrate, and then this is a well-known integral, guys, which is equal to the arctangent of x. And technically there's a plus c. Don't forget the plus c, right? Okay, cool. This tells me u is a constant, I guess, right?
Not quite. No,
Oh, u is a function of
we're
y.
working with a partial differential equation. It's a function of y, but that's why we have our y of squiggly there, or whatever. We'll say that our u of x squiggly equals f of squiggly.
Okay, one sec. U of x comma squiggly. I'm just gonna make it like a fancy e. I'm gonna say, okay. Uxe is equal to, what'd you say?
F of e.
Okay. Okay.
Right. And then, so from there, we can solve for whatever our squiggly value. And then
you mean from this?
Yes. Yeah.
Okay. How do I do that? Where do I solve that from?
When our x equals whatever squiggly, we get our c is squiggly.
Oh,
Yeah,
okay.
So we get y equals arctangent of x plus squiggly thing.
Disqualified.
Dude, what? Squiggly? Wait, okay, let me understand this. Sorry. Y is a function of two different things here, right? So what are these variables representing in? What is this? Y of a comma b? Like what is y a function of? Y is certainly is a function of x for
last
sure.
Semester.
Oh, I think y is a function of x and u, maybe.
I believe so. I gotta take a look back at my notes. I did this like
Yeah. So
way
this
last
says y is
semester.
y is equal to arctangent. No. Y is a function of x and squiggle.
Yeah.
I think. Where we're saying that. I mean, this tells me when x is. I would assume this is x and then this is squiggle, but maybe it's like squiggle comma x. Sorry, it's x comma squiggle. No, sorry, squiggle comma x. Because you're saying that when I plug 0 in for here, I should get squiggle. Squiggly
Yeah, I
value
believe
is
so.
chi. Okay, all right, cool. All right, so when
Oh, thank you. That's helpful.
it's called chi apparently. Okay, so when
Yeah,
x
that makes sense.
equals 0, y needs to go to squiggle, and then the arctangent of 0 is equal to 0. So c is equal to squiggle. Okay. So now I get that y is equal to arctangent of x plus squiggle. X and t, you would say, okay, cool. I like that. I like that better. So you can say like t comma x, maybe. Yeah, let's do that. Y of x comma t. This I think would be y of t comma x though, right? In order for that to make sense here. Because I need when x equals 0 for this to go away, and then c is then equal to squiggle. I think. Who knows?
These are times when I really wish I'd put more work on homework assignments.
It's okay. Okay. Cool. What do we do now?
All right, so then we would say that our t equals y minus the arctangent of x.
T equals y, or you mean squiggle equals?
Squiggle, yeah. I tried
We're
pronouncing it, but
Squiggle equals y. Let's not get fancy here. We're still calling it squiggle. Y is equal to y. Squiggle is equal to y minus arctan of x. Yeah. Okay.
And then because we said that our u of x comma squiggle is equal to f of squiggle,
Okay.
up top here,
Mhm.
we can then say that our u of x comma y is equal to f of y minus the arctangent of x.
U of f comma y is equal to okay, y minus the arctangent of x.
Yeah, because we said that our u of squiggle is f of squiggle, and we figured out squiggle is
Mm-hmm.
our y minus arctangent of x.
Okay.
So we can just plug that in to get our f of y minus arctangent of x. If we wanted, we could go through and now verify that this general solution works.
you
also,
mean
it would be a
F of y, right?
of that whole thing. So it would be a whole like
Oh.
f
Oh.
y minus arctangent
I see what you're
of
saying.
it,
You're saying
because
this.
we could have a whole
F
family
of this whole thing.
functions.
Yeah.
Mhm.
Okay.
And then we would the only other thing is now we would just have to sketch our characteristic curves, which would look like a bunch of arctangents.
That vary with y though, no?
Yeah, exactly. So they would just look like you're stacking up a bunch of arctangents, pretty much.
Okay. Bunch of negative arctangents, I guess, right?
Oh, yeah, I guess it would technically be a negative.
Okay, so yeah, I remember this is arctangent. So negative arctangent's the other way. Right, so it goes from here to here. If I can graph. Can I graph today? Yeah, there we go. like this. Okay. So this would be negative arctangent of x. And then what we're saying is these are kind of layered on top of each other in terms of y.
Yeah, pretty much.
So you have like another one like up here maybe?
Mm-hmm.
Oh, okay, that's cool.
But they would never touch. They would be
They never touch.
symmetrically split.
Not allowed to touch. Okay.
Yeah, and so like here's a book solution for that. It would look something like that.
Oh, okay. Oh, they have theirs different than what I had.
Yeah, because when you had drawn it, it was with respect to the squiggly, right? Because when it's if we're graphing
okay.
our squiggly as our y, then it would look like that. But if we're graphing in the xy plane, it's gonna look a little bit different.
Okay.
And those are the
I love it's in like rainbow. This is so like pleasing to my eyes. Looks pretty as fuck. Wow. Okay, cool. Did we do it?
Yeah.
Did we do the thing?
Yeah.
Nice.
Yeah,
Good job,
that's
guys.
Well
Crazy.
done. Well
Why is it labeled squiggly? I guess that's what we're calling it.
Yeah, I don't know. That's just what the book went with.
Kai apparently is what it's called.
Yeah, I mean, I learned all of the PDE low-key off of STEM Jock. We only had 50-minute class periods, so we would never actually get the time to do an example.
Yeah,
of
that's the
anything.
worst. Yeah, when I taught my in-person class at UCLA, it was 50 minutes, and I'm like, bro, that is not enough time to teach a class.
No,
Like,
not at all.
I barely get into a flow after like the first 30 minutes.
I remember a couple of the solutions we derived to would be like 2 or 3 classes that it would take
Yeah.
just to derive one solution.
Yeah, I'm like, what? I'm supposed to like remember things between classes? That's crazy. Yay, there's a statics question in the queue. Yeah, my teacher always complains about the 50 minutes. Yeah. Yeah, so it's usually you either get 3 classes at 50 minutes or you get 2 classes at an hour and a half. And I feel like the 2 at an hour and a half is like a lot more manageable, a lot more easy to do stuff with. Does that make sense? Yeah, 3 hours. Yeah.
I think it's
Okay.
an hour 15.
You're right. I think that is how it works. Because yeah, the 50 minutes is you have to have like 10 minutes in between classes to like move. My third class is on
Yeah.
Friday, but I never go.
Oh no.
Fati, go to your class. So number one thing a teacher notices is like who shows up. Unless you're in like one of those 200 person classes, and like yeah, who cares? All right, cool. Wow, ooh, the queue got big. The queue got big. All right, let's go. Choose a winner. See what we got.
Let's go gambling!
Or 1 3-hour class? That's too much. Fati, it's you. Thanks for hanging
I'm
around,
gonna have to
Fati.
take one of those 3 hours next semester.
Oh, that's so
gonna be
gross,
rough.
dude. 3 hours is so rough.
Yeah, and then it's got another lab, so it's like Monday, Wednesday, like 2 or 3 hours.
What
a day.
class is it? What class is it? That's 3
college
hours.
geometry.
Okay,
They don't
so
offer a lot
like
math.
college algebra is like a joke. Is college geometry not a joke? I'm gonna guess it's not a joke.
I'd assume not, because it's an upper division course, but I'm not
Yeah.
really sure. It's like all I could take because they offer intro to analysis
Mm-hmm.
and college geometry, and that's the only thing I haven't taken. So, minus stats. I
Right,
refuse to
right,
take
minus
stats.
You
unless
should
I
take
have to.
stats. Take stats.
I
Stats is
will
dope.
eventually, but you know,
You'll do
I
it.
get bored with
You'll
it.
get there. Okay, this is a good. Yeah, this is kind of a basic differential equation. I think the way we solve this is I have to solve for the homogeneous solution, and then I have to solve for like the specific one. Is that what that's called?
The particular solution.
Particular. Sorry. Yeah. I was like,
Yeah,
is it
yeah.
particular or specific? So yeah.
it's
Well,
particular.
I
but
like I
remember.
pretend this shit is 0 just for starters. I'm just like, oh, let's just pretend this is 0. And I think it's called like the general solution. Not the general. Complementary and particular. Okay, maybe it's a complementary one. Okay, so pretend it's homogeneous. So pretend it's equal to 0. This is called homogeneous. Then you have d squared y dx squared plus y is equal to 0. And this, I think you can use the assumption that y is equal to e to the ax. So y prime would be equal to a e to the ax. And then y double prime would be equal to a squared e to the ax. And then you like plug it in and see what we get.
There's two solutions to it. You would want to use your characteristic equation.
Characteristic equation. What do you mean?
So you
Like
would write it
cosine
as
plus
a,
sine?
almost you would treat it basically as a polynomial. So you would basically say that your right, your lambda squared plus 1 is equal to 0.
Yeah, you see that from
factor.
here. I think you see that from here, right? If you assume it's e to the ax, then you can just cancel these e to the ax's out, right? It'll just go away. And then you just get a squared plus 1, right? And that gives you, right, a squared is equal to -1, right? So then a is equal to plus or minus I? Or, right? Is it plus or minus I? I think so.
Yes, I believe so.
Right, cool.
I didn't hear anything you said. My head.
No, you're good, you're good. So you have y is equal to like c1 e to the ix plus c2 e to the minus ix. And yeah, that's, alpha and beta. I don't think we have any initial conditions though. They don't tell us, right? So we have to kind of just leave it. Yeah. And this almost looks like, I think, like a combination of sine and cosine, Fati, right? Okay, and then I gotta solve the non-homogeneous, or whatever the particular one. Yeah. So then we gotta go solve this one, which is difficult. Okay. Yeah, so this is called I think someone was saying the auxiliary. They want you to use variation of parameters, yeah. Okay. Why didn't you go here? There you go. That's where I told you to go. Okay, so then this is the specific. Let me remember if I remember variation of parameters. I know integrating factors. I love integrating factors, but this I don't think this fits the case for integrating factors. Should have parameters. Where's Paul's math notes? I love Paul. Paul's great. Yeah, there we go. Yeah, it's that. It's y1, u1. That's like the simple way to do it. There you go. Yeah. I love where it's just like, yeah, here it is in blue. Here's how you do it. Cool. Everything kind of works because it's like a reverse product rule or like reverse chain rule or something. Okay. So yeah, so when it's in this form, in this case, Q of t, right, there is no y prime, so this is actually 0. I don't even know. This doesn't even exist. Okay. Then the solution is assume y1 and y2 are fundamental set of that's... Okay, oh, we have to move it over. First off, sorry. So you have d squared y dx squared plus 0 dy dx. Yeah, c1 cosine x plus c2 sine of x is for y up there. Yeah, this you could also write as sine and cosine. Yeah, I understand that. And then this is plus y, and then... Oh, wait. Assume they're the solutions of this. Ah, okay. And then is this y1? And then this is y2? Yeah, okay, cool. All right, got you. All right, so this right here is y1. This is y2. Because those are the solutions to the homogeneous. Okay, so then the particular is equal to negative y1. So that's going to be negative... I forget. Do I keep the C1 on it? Maybe we keep it. Let's just keep it. Oh, no C? Okay, don't keep it. Okay. So negative e to the ix. And then it's the integral of the second one, which was e to the negative ix. And then g of t. What is g of t again? G of t is always something fun. What is it? Oh, G of t is the thing is what it... Okay, G of t is the thing on the end. Yeah, this is G of t. Okay, here we go. This is G of t. So it's e to the minus x, e to the minus ix, secant of x, and then that's dx, and then, yeah, this is the... Is it called the Wronskian? It is the Wronskian. Okay. Right, which is the derivative of one times the other minus the derivative of the second one times the first. Okay. Now let's remember this. Yeah. Now, actually, I think it's easier, Fati, if I write this as a combination of sines and cosines. I think that's the easier way to write this. Yeah, the determinant of the homogeneous solutions and the first derivatives. Zach says not really. I was just thinking if the integral would be easier if it was sine and cosine.
Well, you could expand your secant in terms of e to the ix as well.
Okay.
Because it's, well, 1 over cosine, so...
Correct me if I'm wrong, isn't this the same thing as C1 cosine of... I want to say it's... yeah, what's the thing? Is it cosine of x?
It would be a plus
C2.
C2 sine of x.
Sine of x, right?
Yeah. If you work out using Euler's formulas and like cancellation, then it works out nicely.
Yeah, let's do that instead. So yeah, this can also be written as a superposition of cosines and sines. So in this case, let's call this. Zach says, I was trying to take the Laplace transform of secant of x and I realized I'm on a fool's errand. Oh no. Okay, what's up, Bella? All right, so let's call this y1. Let's call this y2. I think it'll just make the integrals easier, especially since g of t is equal to secant of x. Okay. So that's negative y1, so that's negative cosine of x, times y2, which is sine of x. And then we got to do the Wronskian. So the Wronskian looks like this. Right, so it's... this is going to be cosine of x. This is going to be sine of x. And then this is a derivative of cosine, which is negative sine of x. And this is derivative of sine, cosine of x. And so then the Wronskian is like this determinant. So we're going to take the determinant of that. And that's going to be cosine squared of x. Aha! Plus sine squared of x. Love that. Which is just equal to 1. Beautiful. We love that. Okay. Right, so w is just equal to 1 in this case, which is nice. He's determined. Zach with the jokes today. Zach's determined with the determinant. Okay. Cool. So this is just 1. Beautiful. Love it. That's so nice to work with. Okay. And then that's plus y2, which is sine of x, integral of cosine of x, secant of x, dx, all over 1. Okay, then let's evaluate this. Secant is the same thing as 1 over cosine. So this is equal to negative cosine of x, integral of sine over cosine. But sine over cosine is the same thing as tangent. So tangent of x dx plus sine of x. And then this is cosine times 1 over cosine, which is just 1. So that's just dx. Beautiful. So this one's actually really nice, right? Integral dx is just x. So this is just plus x sine of x. Yeah? And then I gotta remember what the integral of tangent is. I think it's like ln of some shit.
ln absolute value of secant of x.
Uh-huh. ln absolute value of secant of x, yes. So then we have... I remember there was ln's in there somewhere. Okay, cool. So then that's y particular, I guess. And then probably need some C1s and some C3s and some C4s somewhere, right? Am I allowed to just like say plus like C3? Because I did a bunch of indefinite. No, Fatih says no. Just like chill. I'm always worried because we did some indefinite integrals, right? Okay. So the general solution, YG, is then equal to, I think, yeah, C1 cosine of x plus C2 sine of x. And then we're just going to leave this, I guess. Minus cosine of x, ln of absolute value, secant of x, plus x sine of x. I feel like they should be weighted somehow, no? Let's see real quick what chat does on this. Actually, you know what? Let's give this to Claude. We're being equitable here. We're gonna let all the AIs get love and attention today on my stream. Okay, there you go. Cool. So I did that. Yep. Right. Okay. Cool. Here's what I'm gonna ask. I'm gonna ask. Why is there no constant on the particular solution? Just curious. Great question. There are constants, and when you compute U1 and U2, but we deliberately drop them because they'd be redundant. When we integrate to get U1 and U2, technically we get yes, good. Plugging these into YP. But notice that A cosine x plus B sine of x is just... Oh, I see. Oh, that's cool. I see. We've already accounted for them. That's cool. I see. Right, okay, so let me explain what I understand from that. So when I integrated this, I should have gotten this like plus like C3, and then that would be... this would have been... Sorry, it would have technically been sine of x times x plus C4, right? But sine of x C4 and minus cosine of x C3 are already accounted for here in the homogeneous solution. We already have like a C, so you just absorb them back in. I thought you said open claw and I got scared. Yeah. But yeah, what we're gonna say is like these are redundant. Yeah, Claude is pretty cool. I only recently started paying for it, honestly. Because I said, why not? It's cool to have a bunch of different opinions. I think each AI has its own like strength. And for instance, I really like ChatGPT for Codex. Codex is really good for writing code. But I think I like Claude better for coming up with the PRD and like planning out what Codex should do. Yeah. Trig says, do you believe there are multiverse universes, if that makes sense? Yeah, sure. I don't see any evidence against it. Which AI do I prefer for math? That's a good question. I actually really like Gemini, I think, for math. Also, Gemini has a lot of cool stuff with the SAT. I think Google is a little bit more focused on the education side of things. I think Chat is more focused on code writing, and I want to say Claude is more maybe humanities based. Wolfram has a GPT as well. Oh, I haven't seen theirs.
It's through ChatGPT. So
Okay.
if you go to like your sidebar on ChatGPT,
Oh, and
it's
like
an
apps or
app
something.
called GPTs, and it's just like different people, modify their AI.
They
for
put
what
weights
they
on things
need.
and stuff.
Yeah, and train it how they want. And Wolfram has
Kling
one.
is fun. Yeah,
It works
Kling,
pretty good.
Kling is people creating all the videos and picture stuff, right? That stuff's funny. I've seen Kling AI before. Nice. Okay, good question, Fati. Thanks for asking this. Good luck on your test in 2 days. I think this is a pretty good question. That was Sora. Yeah, Sora got discontinued. I think they noticed they were aware that what was it? It was just eating into their costs, and Chat's trying to like stay solvent. So they said, okay, no more generating weird video picture things. Again, I think Chat is pivoting more towards code or like government surveillance.
Oh no.
Yeah, whichever comes first. Yeah, Sora. Yeah, Sora died. But I mean, Google has Nano Banana, which is really cool. Midjourney's still around, I'm sure. Yeah, it's a wild world, the AI world. It's fun. Sora did get shut down. Yeah. Okay. But yeah, I had to interview some people today for some positions that the company I'm working at is hiring, and one of the people was involved in like education and like has a child, and I think we came to the same agreement that AI is inevitable, and it's really it comes down to like how you use the AI in education on whether like it helps you or it hurts you. And so if you're using it to copy answers, you're just hurting yourself. But if you're using it to learn and like using Socratic styles of learning, like if you're asking questions to the AI, like I just did there with Claude, I said, hey, wait, why do I not have a C3 and a C4 on this? And then it shows you, it's like, oh, wait, because this is redundant. I'm like, okay, cool. That makes sense. I understand now. Yeah. Ask questions. I think that's probably the number one thing that people need to learn. Maybe it's a skill they should teach is how to use AI, is how to prompt it, and not in a lazy way. Because if you prompt it in a lazy way, you're going to get lazy results and you're not really going to learn much. But if you're clever about what you ask, it'll give you pretty clever insights, I think. I think it's... Oh, the fruit Love Island slop. Yeah. That stuff's like too much. Okay. All right. Cool. Let's go choose another winner for our questions. Who's it gonna be?
Let's go gambling!
Why am I racist? We won. Okay. Ooh, this is cool. This looks like it's in Arabic too, actually. Wow. Why am I racist? Which question did you need help with? You told me earlier. Sorry. I think you told me like 3 and 5, maybe. Let me see. I remember in the chat earlier. Where's my... Okay, here we go. I uploaded my question. Solve the 3rd and 5th A part. Okay, so I think this one and this one, and then I think this is what they want. 3rd and 5th. Solve 3rd and 5th A part. Okay, cool. For both. For both. Interesting. What does both mean? Does both mean like this? This is interesting where it says like or. I would imagine if these two were similar questions, you could like solve either one, but they're kind of the same question. They're very different questions. They're not the same at all. Is that Arabic? I believe it is Arabic. It looks squiggly. This is the OG squiggle. Can I solve 1D wave questions? Yeah. Yeah, 1D wave? Yeah, 1D's okay. I should be able to solve a 1D wave question. Cody? Okay. Yeah, don't worry, Pineapple. Universities know about grade inflation, and they know about people using AI to just like cheat on exams. This is where standardized tests hopefully kind of create more of a equitable solution, because you can't cheat on, or you shouldn't be able to cheat on a standardized test. PDEs, I could try to solve. I did do a PDE question earlier today.
I could probably help out if it's 1D wave. I should be able to.
Breasticles is heavy support here for the PDEs.
Familiar with that.
Yeah. Exactly. Yeah. Okay. All right. Let me try to do this one. Okay. Radioactive substance decays according to the formula M is equal to 200 times 10 to the negative 0.05 T. Great. Okay, cool. I'm assuming this is the Arabic form of it. Use logarithms to express T in terms of M. Oh, that's fun. Okay, so let's use kind of a smaller font. Sorry. A little bit thicker. There we go. M is equal to 200 times 10 to the minus 0.05 T. And you're trying to isolate T. So if the variable you're looking for is up in the exponent, what you're going to want to do is use logarithms. That's how you get things out of exponents. I'm going to first start by like dividing this by 200. Just because I don't want to see this thing here. It's kind of like weird. Just put it over there. So this would be my first step. Okay. I don't know why these things got squiggly. All right. And then in order to bring this down, what you want to do is you want to take the log of both sides. Now, you get to pick what base you want. Usually you want to pick the base of your log to be the same thing as the base of the exponent you're taking the log of. So in this case, I'm going to pick log base 10. Which is the same thing. If you hit log on your calculator, it's usually just log base 10. In math, technically log is ln, I'm pretty sure. You have to say you have to say log 10 in order to technically get the 10 one. Survived advanced functions 12s, physics 12s, and vector calc. Incoming. Awesome journey, but you're half dead. You're half alive. I'm Mokiato. You don't have to write the 10. See, that's debatable, Alistair. Because technically, if you ever look at like Wolfram and stuff, log is technically log base E. This is not log base 10. So I'm gonna write it just to be safe.
In fairness, Wolfram does it as like a complex log most of the time, though. They consider the full complex value. Yeah, but it depends. But I just throw the 10 anyway. It doesn't really matter.
Yeah, it's not the worst thing in the world. So, okay, so when you do that, you get log base 10 of m over 200. And then here, because this is in the exponent, the log of something to an exponent, the exponent is going to come down out front. Okay? So what you end up getting is minus 0.05 t, and then it's log base 10 of 10. And the cool thing is log base 10 of 10 is just 1. Love that. Okay? So then you just divide. And so you get... this is the same thing as negative 1 over 20. Because now I can just multiply this by negative 20. I'm going to say, okay, cool. So negative 20 log base 10 of m over 200 is equal to t. Yeah, anti-log's the other one. Yeah. A log 10. I've seen that one as well. Yeah, Mathematica doesn't even have ln. Yeah, they just say log is. Okay. Okay, cool. And then, yeah, if you wanted to solve for this, I'm not going to do it, but It's easy. You just plug in m equals 100. Which is actually going to be the half-life time. Right? That's the amount of time it goes from 200 to 100. Yeah. Okay, cool. Let's try to do this one. I think this is a cool, like, little trig identity. So we have sine theta over 1 minus cosine theta is equal to, I think that's cosecant. So I'm going to say this, cosecant theta plus cotangent theta. Wow, okay. Alright. I am tempted. Let me think. I feel like I want to multiply this by a conjugate. Yeah, exactly. Yeah, Jeff's right.
Good job.
Yeah, let's multiply by the conjugate. Let's multiply by 1 plus cosine theta. Yeah. It just looks nice, right? Yeah, because watch what happens. So now, that's going to give me... What's up, Alistair? Appreciate it. I do need the water. I'm going to get sine theta plus sine theta cosine theta. And then this is all
over. This is a difference of squares. So that's going to be 1 minus cosine squared theta. And then something you learn, this is like one of the most important identities in all trig. Sine squared theta plus cosine squared theta is equal to 1. Always know that one. So that tells me that 1 minus cosine squared is equal to sine squared. So now I have sine of theta. Okay, let's just copy this.
easy. So this is the same thing as sine squared theta. So then let's divide out the two fractions. So I get 1 minus sine of theta. And then this is going to be plus cosine theta over sine of theta. And this is the same thing as cosecant theta. And then this is the same thing as cotangent of theta. And bingo, bingo. Same thing. QED. Nice. Maybe let's do this one they need help with. Find the square root. Excuse me? What? Find the square root? What square root of what? What? Is this question even asking? Do they literally want me to do this? I don't know if that actually like helps me out. Yeah, I think it's probably factoring. Yeah, I agree. Could be. It's a trinomial being squared. Okay. Let me think how that works then. Okay. Yeah. So we could say that this could be written as, like 2x squared plus some ax plus 5. The reason for that is when I do this, I'm going to get, this will be the highest term squared, which is the 4x squared. This will be the lowest power term, which is 5 squared, which is 25. And then we just need this to work out. Zach says, let a equals 3. Done. Okay. Let me try to, like, show... I mean, you could just guess that, I guess. But if we wanted to do this, like, methodically, I think this is how I would do it. I would say 2x squared, ax, 5, 2x squared, ax, 5. Sam with another hydrate. What's up, Sam? You pull any more legendary Pokemons? I don't know who's in like Pokemon stuff, but Sam showed me some cool stuff. He apparently pulled. I don't know. Do you guys know this Pokemon card? Is this like rare or something? This is apparently the card he pulled. Mega Charizard. I know there's a whole like game around like buying packs of things, and it's like basically the lottery. You got a PSA submission going out tomorrow. Nice. That's cool. Okay, in this case, right? If I were to like work out what the multipliers would be here, so this would be like 4x to the 4th. Nope, we lost that. This one would be 25. And then here you would get 2ax to the 3rd. This would be 2ax to the 3rd, right? And then this is like 10x squared, a squared, x squared, 10x squared. And then what is this? This is 5ax. 5ax. So expanded out, you'd get 4x to the 4th plus 4ax to the 3rd plus 20. Wait, plus. Let me make sure that's right. Sorry. Plus 20 plus a squared x squared. And then plus 10ax plus 25. And then, yeah, you can kind of just match them up by terms, right? So I need a to be something such that this is such that 4ax cubed is equal to 12x cubed. So this is a equals 3. And then I think you just check it for the rest, right? Look, yeah, a equals 3. Because this would become 29. And then if a is equal to 3 here, you get 30x. So yes. So cool. The square root of that is just then equal to 2x squared plus ax plus 5. Is it technically plus or minus? I think maybe they just take the positive root. Sorry, not 2ax. 2x squared plus 3x. A equals 3, yeah, that's what I'm going to say. And then I think it is plus or minus, so no? Not in this case. Okay, not in this case. All right, we're just going to leave it. Nice. Okay, cool. I think we did them. Good questions. These are fun. I think the square root's also given as positive, yeah.
Well done! Well done!
Okay. If you were solving p squared is equal to q of x. Okay, yeah, okay. I always, yeah, get confused which. Square is given as positive. That's the principal square root, yeah. It's like one of the basic things, even when I was tutoring, when I first started tutoring students, and, you know, I was doing like 6th grade math. And they're like, what's the square root of 25? I'm like, it's plus or minus 5. And they'd be like, nope. It's wrong. I was like, oh, okay. Technically just the positive one. Explains why y equals square root of x is always positive. It's a pedantic convention, I agree. All right. Let's see. What are the questions we got in the queue? Let's spin the wheel. See what we got.
Let's go gambling!
Wait, no. We have to actually, it has to spin first. There
Let's
we go.
go gambling!
Oscar! What do you got for me, Oscar? Ooh. This is kind of fun. This looks like calculus, right? Gets on soapbox. Relations are more natural than functions. Is that what it says in the King James Bible? That's, you know, that's the authoritative reference for what is natural in this earth and not. W soapbox. Okay. Book buyer the bookkeeper followed me. Thank you for the follow, book buyer bookkeeper. Okay, use the derivative to show that the graph of the quadratic function for a is greater than 0 is decreasing. Okay, so let's look at what the derivative is, right? So if f of x is equal to ax squared plus bx plus c, then f prime of x is going to equal to 2ax plus b. Okay. And okay. So we want to know when this is positive and when this is negative. Oh, this is actually really cool. So, I want to know when this changes from positive to negative. So we're going to say changes from positive to negative when f prime of x is equal to 0. Okay. That's like the critical points. Yeah, so that's when things will change in terms of slope. Thou shalt not cast relations to functions.
Disqualified.
Okay. So let's set this equal to 0. So 0 is equal to 2ax plus b. So then x is equal to negative b over 2a. Cool. So that's kind of our... If we draw on our line, right? Unless the relationships are 1-to-1. That's good. Okay. So this is... let me like... Sometimes I need to like label things. This is x. And then we're going to call this like f prime of x. Okay. So at negative b over 2a, f of x is equal to 0. So let's look to the left and to the right. Okay. So, okay. Decreasing is when f prime of x is less than 0. Okay. What was my favorite subject topic in high school? Physics. That's why I went into it for my graduate and undergrad and whatever.
Oh, yeah.
I really liked physics. Also because my physics teacher, his name's Mr. Ripito. He's a really dope guy. He was also kind of the head of the robotics team. And I got into robotics in like middle school. And through this guy, I think his wife was our mentor / coach for the middle school team. And so then when I got to college, not when I got to college, sorry, when I got to high school, I did a lot of robotics as well. And so it goes to show you, if you have a good teacher, it really does make a lot of difference. I had like a cool teacher for bio for sure, but I don't know. My bio teacher kind of like more like joked about things. His name was Mr. Perzan. He was a cool guy. He had kind of like a cynical view on life, I guess, which was funny. So I wasn't like, I guess, super hyped about biology. I think if I hadn't done physics, I probably would have done chemistry, because I had a really cool chemistry teacher as well. But physics was, yeah, I just liked it the most. All right, cool. So let's say 2ax plus b is less than 0. Okay. So x is less than negative b over 2a. Cool. So that's when it's decreasing. Nice. And increasing. Yeah, Lego Mindstorms. Yeah, exactly. Yeah, that's kind of like the intro robotics you can get into for sure. So, what is it? 2ax plus b is greater than 0. Move things over. X is greater than negative b over 2a, which I think these are the two things you wanted to prove. You could also like plug values in here, I guess, if you wanted to. Yeah, this is negative. This is positive. Nice. Also, I mean, and that's for a is greater than 0, right? Yeah. A is positive, because if a was negative, that would flip this.
Oh shit, not good.
Right? Yeah, I think this is assuming a is positive. I guess it doesn't matter if b is negative or positive. I always get a little bit confused with the inequalities. I will say also that ax squared plus bx plus c looks like this. It has to look like some sort of positive quadratic. And that will always be like decreasing and then increasing. And then negative b over 2a is actually, if you wanted to prove it, right, this is also the local, or it's actually like a global min. You could also solve that if you looked at whatever, like, f double prime of x, in this case, would be equal to 2a. And if a is greater than 0, f double prime of x is always positive, which means you're concave up. So that tells me that this critical point, located at x equals minus b over 2a, has to be a global minimum. And if it's a minimum, that means anything to the left of it has to be decreasing, and everything to the right to it has to be increasing. As long as there aren't any other critical points. That's another argument you could say for this, I think. Probably a stronger one. So yeah, I'd say concave up. Only one critical point. So, to the left of critical point, f prime of x is negative. To the right, f prime of x is positive. Yeah, that's another way to say it. Cool. That's kind of a fun question. Thank you, Oscar.
Well done! Well done!
You're in robotics now? Vex robotics. Yeah, Vex is cool. See if your high school has a what's called like a first robotics team. That's what you really want to get into. If you can get into first robotics, that's really cool. Yeah, FRC. Yeah, I did first robotics. That's like they're big robots. They're super cool. Yeah, FRC's great. My team, we went to global actually, and I think we won. Or we were on Einstein, which is like the final field. Yours is 6977? Yeah, mine's 1477. 1477. Let me see, Texas Torque. This was my team. 1477. Yeah, this was us from the Woodlands, Texas. Achievements. Yes. This was the 2013 championship. I think we won. Yeah, I think we won. This is my wait. What? I don't want to. Man, that's my physics professor right there. Damn it. I want to see it. Here, maybe the Woodlands Online will have it. Oh man, this is so long ago. 2013. Yeah, what is this? 13 years ago. Yeah, we've been around for a while. Let's see if I have any pictures of me doing it. But yeah, they've done really well now in the future. Yeah, I wouldn't recognize anyone here. This is so when I did this was 2000 2008 2007. I should join it again. Yeah, I should look into if there's a. Okay, great. Okay, here we go. Yes, this is. Wait, why can I? That's Mr. Rip. He was my physics professor or teacher or whatever. He's really cool. Super awesome guy. Okay, let's go see. Yeah, my goal would be to join back all the organizations that really helped me like grow up into who I was, to like kind of help back. I really liked Boy Scouts. Boy Scouts was great. I think they went through a little bit of problems.
Oh no.
Recently, or not recently. But I really like camping, and everything about Boy Scouts was really cool. Like the Pinewood Derby, there was so much fun shit. I need like my own kid to like kind of guide through that, I think. Because I don't know, maybe it'd be weird if I didn't have my own kid in the program and I was just like volunteering to help. I'd be like, why are you here? Robotics I could do though. Yeah, that's chill. Robotics is chill. Okay, let's go find another question. Can you solve a heat equation on a sphere with an initial condition? Maybe. That sounds kind of tough. I don't know. Let's go choose a winner, though.
Let's go gambling.
I feel like I went into Deca. Yeah, Deca's cool. I've heard of Deca. It's Zetra. Zetra, what do you got for me? Ooh. This is statics. Kind of statics, yeah. This is cool. I think I'm gonna do this with Torque, though. I don't like you guys using this moments thing. And actually, yeah, wait, this isn't engineering, because I don't see any mention of moments. They actually do want to know, like, tension and things.
I still think that's statics. Like, I was looking at my buddy's statics homework, and it's all just
Yeah?
free body diagram. The draw a complete free body diagram with the beam is
That's physics, dude.
experience.
This is physics, dude. We do this in physics.
Yeah, that's why I told him, I was like, so statics is just an entire semester of free body diagrams?
Exactly.
He
Yeah,
was like,
but
yeah, pretty much.
they make them, like, nightmare hard. Like, they'll put, like,
Yeah.
18 different forces and shit. It's just monotonous.
Yeah, pretty much.
I think you described it well, right? It's the definition of just, like, busy work, I feel like. Because you can get the concept pretty easily, but then they just make it so laborious to go through. And that's kind of like what tests who passes and who fails. It's annoying. Yes, free body diagrams are dope. Okay. Okay. Free body diagram of the beam. Let's do it. Okay, so you have the beam. You're gonna have some forces acting on the beam, right? So I assume we're gonna have, at this point, this is gonna be like force of the hinge. All right, let me get like a little thinner pen. Okay. Force of the hinge in the X direction. Probably also gonna have some force of it and the hinge up in the Y direction, I'm gonna assume. Then you have, let's see, you're gonna have tension from the rope. You're gonna have the mass pulling down, and then you're also gonna have the mass of the actual beam. Yeah. So here's what I would say. So this is gonna be force tension. This is going to be force of the little mass. And then this is going to be the force of the beam. Or the gravity of the beam, I would say. Cool. What is the tension in the wire? Okay, cool. Alright, so let's add up what all the forces would be. This is going to have two components to it, right? So we're going to have, I'm going to say like FTY. Then we're going to say like FTX. And I think everything else is good. I think our coordinate system's all right now. Okay. So some of the forces in the Y direction. You got FTY pulling up. You got force of the beam pulling down. You got the force of the mass hanging on it pulling down. And then I'm going to assume positive force of the hinge pulling up. The hinge one kind of like screws with people. But because this is like connected to the wall, you can think of like the hinge is like kind of like pushing into the wall. And so the wall has to push back. Sorry, the beam is pushing into the wall, so the wall has to push back on the beam. And it does so at the hinge. So that's why we say it's like the force from the hinge. Okay, then let's look at the forces in the X direction. That's going to give us a positive force of the hinge in the X direction. And then we're going to say minus FTX. Okay. And let's try to like describe like things we know. So we know this is just equal to mg. So this is going to equal to 15 times 9.8. Right? So I know that one. That's okay. The beam... Oh, wait. No, sorry. The mass it's connected to is 10. Sorry, this is 10. Times 9.8. This one is 15. The whole beam is 15. Let's like move it over a little bit. Also, we know if this is 5 meters long, that force of gravity on the entire beam, that happens at the halfway point on the beam. So that's going to happen at 2.5 meters. And then they also tell us that this one is located, I want to say 1.5 meters from the end. What's up, man? Good to see you, Visible. Visible Sliffs. Sliff? What's a slift? And then we have some angles. I'll get the angles later. Well, okay. If this angle here is 75 degrees, then that tells me what this angle is, right? If this is 75, that tells me this is 25. Let's call it 25 degrees. And then if that's 25, then when I draw this as like a transversal, oh, sorry. Oh, it's 15. Yeah, you're right. Yeah, duh. Yeah, sorry. 15 plus 75 is 90, not 25. I wanted things to equal 100. This is going to be 15. And then I don't think actually I don't think I need to know anything else. I think we're good actually. I'll show you why. I'll show you why later. It has to do with like torque being either perpendicular distance times force or perpendicular force times distance. That's true, breasticles. You're right. Yeah, we never said it was uniform. Okay. So I have FB, I have FM. Great. I don't know what FHY is, and I don't know what FTY is. Okay, so that's two unknowns. I also don't know what FHX is, and I don't know what FTX is.
You done messed up,
Okay, so there's kind of a lot of things that are missing. There's 4 things that are missing, really. Right, I don't know these two. I don't know these two. So I need another equation, is what I do, in order for this to work. And because I can't solve this with just 2 equations. So the next equation you need is the sum of the torques. Okay. And in that case, we get to pick a rotation point. I'm going to pick my rotation point to be here. I'm going to pick this as like my rotation. Because now I don't have to worry about HY and HX. I can just consider these things. Okay. So let's look at all the torques that are causing this thing to rotate this way. Which those are technically negative torques. Right? Yeah. Positive torque is clockwise. So that would be negative FB. And if FB is pointing straight down, I now need to know what the left-right distance is to where that force is acting. So here's what you could do. You could do this times this and then the angle in between the two. Or you can do up-down force times left-right distance, okay? And with left-right distance, if this is 2.5, then I need this distance, right? So that's going to be 2.5 cosine of 15 degrees. So I'm going to say minus FB, then I'm going to say 2.5 cosine of 15 degrees. And then this one is minus FM. And then same thing, that we need a distance. Well, if this is 1.5 from the end to here, then from here to here has to be 3.5 for the whole thing to be 5. So that's going to be 3.5 cosine of 15 degrees. Should I take physics? I've been taking math for my entire life, and I feel like physics would be a bit easy. No, wait, what? Physics can get very tricky for sure. I think you should definitely take physics for sure. If you have an appreciation for math, physics is a cool real world application of math. But I wouldn't be so quick to say, oh well, physics is going to be cake, because definitely not. It can get really tricky for sure. Okay. All right, and then the next thing I need to do is I need to figure out the torque due to this thing. Okay, cool. So, what do I want to do here? I could treat it as two different forces, right? And in this case, right? This one's going to pull it this way. This one's also going to pull it this way. So we could say this is plus, and I could say like FTX. And then because that's a left-right force, I want to know what the up-down distance is from the point where the force is acting to the rotation. And so again, that makes a right triangle. So that would be 5 sine of 15 degrees. Because notice that's up, down. And then that would be plus FTY. And then that would be 5 cosine of 15 degrees. Okay, cool. Three equations, 4 unknowns. dy dx is x squared, Oscar says. Anti-log? You guys are saying unrelated things. Okay. I think the last equation I need has to do with FTY and FTX. I think. Because I need 4 equations, right? I only have 3. I think we know if theta 2 is 60 degrees, then this is 30, right? So then I know that I can do a trig relationship here, right? So I can say the tangent of 30 degrees is equal to FTX over FTY. Shouldn't be a plus for the sum of the x directions. Wait, for here? Well, no, HX points to the right and TX points to the left, no? I think I'm implying the negative.
Oh, yeah, I see now. I see.
Fembox says, be careful. What's wrong? What's wrong? Fem, what am I doing wrong? I think I'm allowed to say this. Oh, wait, I did fuck up. My bad. Yeah. The 30 is wrong. Sorry. Yeah, this is not 90 degrees, dude. I should be able to see that.
Oh no.
Oh, that's bad. That's really bad. My bad. Sorry. I fucked up. It happens. Okay. Sorry. All right. Let me think. Actually, can I get that angle? I know this is 15. Right? And then if that is... You love the evil cat, yeah. Theta 2 is 60 degrees, right? So then this has to be 45, right? How do I get that last angle? Oh, wait a minute. If this is 45, this is 45. Yeah? We agree with that? Because that's a transverse? Okay. So then this is 45 degrees. Ah! Very cool. That tells me FTX equals FTY.
Oh, yeah.
Wow, that's actually really cool. Tangent 45 degrees is just 1. FTY. Cool. That actually helps me out a bunch. Damn, nice. Okay. So, I don't know. Let's just call this, I don't want to call FT. Can I call F little t? Call F little t. Beautiful. Okay. So this is F little t. 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 So actually the cool thing here is because, and I know this is all equal to 0, right? Sorry, some of the forces equal to 0 in X and the Y direction, some of the torques equal to 0. I know numbers for all these. Yeah, so let's use this. Oh, you know what's actually fascinating? Yeah, to find the tension in the wire, I actually didn't even need this.
Surprise, motherfucker.
I didn't need any of that. Okay, cool. So I'm going to say FB times 2.5 cosine of 15 degrees plus FM, and then let's get values for these. So FB, we said, was 15 times 9.8. So 15, 9.8 plus 10 times 9.8. And that was also cosine of 15 degrees. Is equal to, and then this is F little t, and then this is going to be 5 sine of 15 degrees plus 5 cosine of 15 degrees. Yes, 3.5 here as well. Yep, I fucked up on that one too. Wait, no, wait. Oh, yeah, sorry. You're right. Here, I forgot the 3.5. Again, this is why this is probably an engineering question, because they're trying to trick you up on just number, like data entry, which is annoying. Okay. All right, let's get the calculator out. Okay. All right, 15 times 9.8 times the cosine of 15 plus 10 times 9.8 times 3.5 times the cosine of 15 degrees. Okay. All of that divided by 5. And then divided by sine of 15. T94 gold, yeah. Cosine of 15. Okay. So you get FT is equal to 77.3 newtons. So FT is equal to 77.3 newtons. But then FT, the total, right? That's equal to the square root of 2. Square root of 2 FT, I think, right? Because it's this type of triangle, right? This is like F little t, and then this is big FT. Yeah. You have a present in the chat for the community. Oh, that's nice. So anybody wants to click that, you go get free nitro, I guess. I already have nitro. But I appreciate that as well. Okay, so that's 1 point... well, let's just multiply by the square root of 2. So that's what? 109.3? Newtons.
Good.
Nice. Of course, my roommate bought it the time I gave it to her. Nice. What's up, Cody? Did I do something wrong here? I feel like this is okay. Oh, wait, never mind. Okay, cool. All right, you're good.
Good job.
What in the... I'm pretty sure you can just click it. Whoever claims it first just claims it. It's gone. Already? Okay. Whoever got it, congrats. I appreciate that, Bella. Thank you. Yeah. Okay. So that's done here. So we've done part B. What force does the hinge exert on the beam? Okay. So now we need to use this to find out FHX. Okay. Okay. So FHY is equal to F little t plus FB plus FM, and then FHX is just equal to FT. Okay, cool. So this is... The answer says 158. Uh-oh.
Oh, no.
Okay, where did we mess up? Okay. I am fallible sometimes. Negative sign in the FHY. Oh, you mean... oh, sorry. There's a minus sign on this one. Where did I screw up, Corey? Let me see. I make mistakes. Everyone makes mistakes, dude. It's okay. I feel like that's okay. Theta 2 is that's 15. 6 but that whole thing there is 60 degrees, so that's 45 degrees. But then, yes, that makes a 45-degree triangle. 45, 45. I think FTX equals FTY. I'm cool with that. And then if this here is 75 degrees, this should be 15. Right, yeah. And then 5 meter mass, so 15. Let me just make sure that's right. 15, 9.8, 2.5. Yeah, cosine 15 degrees. Uh-huh. 10. And then that should be 3.5. Yeah, no, this is all correct. This is correct. And then that should be... yeah, FTY should be 5 sine of 15 degrees. Yeah. And then that should be 5 cosine of 15 degrees. Yeah. Let's check. I'm pretty sure the calculator's in... it's in degree mode. Yeah. Calculator's in degree mode. For sure. Let's see. What went wrong? 15. Oh, yeah, I forgot the 2.5 here.
Oh no.
Obviously, don't go and do that.
This
back
is
to
why,
the
dude. The
lab.
data
We
entry,
can't
like,
condone
get
anything of the
fucked,
sort.
bro.
Oh no.
It's the data entry, dude. It's so annoying. I see. Okay, one sec. I hate the data entry. Okay. It's 2.5 here. We forgot the 2.5. There we go. 15, 9.8, 2.5, cosine 50, 10, 9.8, 3.5, cosine 15. Good. Okay, now that divided by 5, and then divided by sine of 15. I'm going to check it. I'm going to check it right now. Plus cosine of 15. Okay, there you go. 112. Yep. I think this is going to fix it. This is just an annoying bitch of a question. All right, then times the square root of 2. There you go, 158. That's what you guys wanted, yeah? That's correct. Yeah, 158. 158.5. Is that good? Yeah. This is one of the things where, again, this is important. When you're taking a test or doing homework, if you write out this and you get the wrong number, you'll get partial credit. Your teacher will just be like, yeah, okay. Like, I get it, bro. Just forgot to put that in the calculator. What's more important is you understand, like, the process and the thinking behind it. Data entry is going to get replaced by AI, 100%. You don't need to be good at data entry. Nice. Okay, good. All right, we got that. Okay, so then that's 112 newtons. Okay, so then let's figure this out. Right, that goes over, that goes over. This one's negative. You're right. Okay, so that's equal to negative 112 plus the force of the beam. So plus 15 times 9.8 plus 98. So let's see what we get there. So I'm going to do 98 plus 15 times 9.8 minus 112. Okay, so then FHY is equal to 133 newtons. Okay, so then FH total is the square root of FHX squared plus FHY squared. So let's just square those two things. So this squared plus 112 squared square root, and we're gonna get 174 newtons. Is that the force on the hinge? Let's see what YouTube says. I guess we should find the angle as well. I mean, we could. It's just the arctangent of that, right? I assume they just want the magnitude of the force. It's 174 for the answer. Close enough. It is the answer. 174 is correct.
That's dope.
I guess it's close enough. Oh man, what a pain. But cool question, actually. Nice. Okay, cool. So Zetra, if you have any questions about that, please feel free to ask. But also, we'll post the solution here for you. Force is a vector. Yeah, go get the angle if you want it. It's just arctangent. I assume you know how to do that. But there you go. There's your solution. And then also there's a little timestamp there if you want to go through. That question took 26 minutes for us to do. Wow. It'll be there as well. Cool. Yes. So make sure, if you want access to all the stuff we do, we also have, we play video games, we give out prizes and all sorts of fun shit. You can go join the Discord there. The same website you use to submit the questions, just click join the Discord. Yeah, you're very welcome, Extra. That was a fun question. It was a little long, but it was fun. I think what would be cool is to like just build some sort of AI thing that would, again, once I write this out, I would like just the algebra just to happen. I don't want to have to type this in. It's a pain. But okay, cool. All right, let's go spin the wheel. See who our next winner is going to be.
Let's go gambling!
Really? That's cool, Breasticles.
Yeah.
I know Mathematic Fanatic has a whole like visual thing that'll show it. Okay, what do we got? What's this? Ooh, okay, this is probably you, right?
This is the wave equation.
This is the wave equation. Okay.
Yeah, get up here. This one.
All right, thank you, please. Let's. This might be the last question of the day. Okay. The pressure of gas in a tube is represented as follows. Yeah, what's up, Cody? Okay, where c is the speed of sound. The tube is open at x equals a, so the pressure fluctuation at this point is always 0. And there's a loudspeaker at x equals 0, which modulates according to p0 of t is equal to p naught sine omega t. Okay. By substituting into the wave PDE, show that any function of the form that is a valid solution. Okay. Do we just calculate what these things are, I guess?
For number 1, you can just take your pxx and pyy and just substitute it in, giving your general solution to the wave equation.
But this says f of x plus ct.
Yeah, so that's our general solution to the wave equation. Technically, what that represents is your x plus ct is your backwards traveling wave, and your x minus ct is your forward traveling wave.
Right. Okay. Substituting into the wave, show that any function of that form. Okay. Because usually when I see some diffie-q, like they give me like something, and I just start taking derivatives. But
yeah, you could just take your derivatives. And technically, what you could do if you want, for one, is given the linearity of your wave equation, you could just take your partial derivatives of your f and your partial derivative of your g, and if they both satisfy the wave equation, then you know that your p of x, which is a sum of them, is also going to satisfy your wave equation.
Okay.
By properties of linearity.
I think you write the partial of t in terms of p. I think you just do this, right? So px would just be f prime x plus ct and then times 1, right? Because it's the chain rule, yeah? Okay. And then that's plus g prime, and then that'd be x plus ct times 1.
Yeah, and I'd say for clarity, it would probably be easier if you say f sub t or f sub x as well, and g sub x, just because you're also going to have to take the derivative with respect to t.
Okay, so pxx is then fxx x plus ct, yeah? Plus gxx x plus ct, x of ct.
Yep.
Okay, and then let's do ptt. So pt is going to equal to ft, but then that's going to pull out a c. So I'm going to say cft ft x plus ct. Wait, and then this one was minus. And then so this is minus c gt x minus ct. So then ptt is equal to c squared ftt x plus ct and then this is plus c squared gtt of x minus ct. Yeah?
Yep.
And then I just plug that in, right?
Yeah, you can just plug that in.
Okay, so if I plug this into here, I just get what I have, right? So here, plug this in. You get that. All right, let me copy this from this. One sec. No. Okay. So this corresponds to this, and then we have over 1 over c squared, and then there's a c squared you can pull out of this, so I'd say c squared, so that's going to cancel. Nice. And then that's going to be FTT x plus CT plus GTT x minus CT. Yeah. Okay. And then I guess that's what the wave equation is, right?
Yeah, that's just another wave equation.
So you just say this is a valid solution, QED?
Yeah,
Okay.
because technically you could say that PTT over C squared is equal to that right-hand side, and then PXX is equal to your left-hand side. So you just end up right at your PXX equals 1 over C squared PTT,
Okay.
which verifies that.
Cool. Bloop, 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 bloop. Yeah, okay. Use separation of variables to find the particular solution. Uh-oh, maybe this is scary.
Sounds scarier than it is. So what separation of variables is we're gonna assume that our P of xt is in the form capital X of X and capital T of T.
Okay. All right, 2 is what tripped me out. Okay, so I'm going to say, P of T?
X and P of X comma T.
P of X comma T,
Rather.
yeah, is equal to some equation X is a function of X and some function T is a function of T?
Yes.
Okay, I agree
And
with
that's just a general form for how we do any separation of variables. It's always going to be like your original starting point.
that.
And what's nice about this in this case is since we already know our P of 0t, we can just say that T of t is sine of omega t.
All right, so one sec. So yes, okay. So from this, so here let's take that. Let's like highlight it. Okay, so P0 comma t, because that's where the source is equal to P naught sine. I'm gonna just say omega t. I'm gonna use the lowercase omega. Okay, so that tells me that this is
So
equal to 1, maybe?
Not quite. So
Not quite.
what that tells you is that your X of 0 multiplied by your T of t is equal to P naught sine of omega t.
Okay, sorry. Say it again. Sorry. Say it again.
So that tells so your X of 0
Yes.
is equal to P naught, or not your X of 0 times T of t.
Got you. X of 0 times T of t is equal to this. Yeah?
Yes.
Perfect. Okay, cool. I understand. And then do I want to use the other condition? The one at X equals A? And I just say it's
so
equal
we're
to
not
0?
going to use that just yet.
Okay.
What is nice about this, and this is just to make our life easier, we solve less equations if we do this, is if you move your X naught over, because our X naught is going to be a constant, right? We can absolve our P naught over X naught into our X of X because they're constants, and just say that our T of t is going to be sine of omega t.
Interesting. Okay.
Right, and then we absolve that P naught X naught.
We just say
X
these are
of
both
X.
these are both constants. And we're just going to say that's equal to X of X?
No, not quite.
Okay.
Well, the constants go into x of x, but what we can do here is now say p of x comma t is equal to x of x sine omega t.
X of x sine omega t. Oh, thank you, Isabella. Thanks for the donation. Study money. What currency is that? 89 DKK? What is DKK? Okay. All right, so P of x comma t is equal to, sorry, say it again.
P of x comma t is
Yep.
equal to x of x times sine of omega t.
Aha. Okay. So you're saying T of T
And
is
then-
equal to sine omega T?
Yeah.
Okay.
Just because we can just say it's t of t because we're just bringing that constant as part of our x of x.
Okay.
When we solve x of x, that constant just gets accounted for in the process of solving it that way.
Okay.
And so now we just know what t of t is for it,
Okay.
which
Interesting.
makes our solving a bit easier. So then we can figure out our PTT and our PXX.
Okay. So PTT is going to equal to XTT of T. Would it be X of X? Zebro saying, is it X of X times sine omega T? I guess so, right?
Yeah, it's x of x times.
Yeah, my bad. Thank you, Zebra. All right, so this is XTT of X. Wait, but X isn't a function of T.
Yeah, so we treat it like a constant in this case.
So it's just a constant. Okay, so that just chills.
Yeah,
Okay.
that's kind of the whole like concept of separation of variables is we're basically saying in this specific
Okay.
form, when we take our derivatives, they basically just have to be equal to the same constant, which
Okay.
we can then
So this is
solve for
X,
these two
X of X, and then this is going to be omega squared minus omega squared sine omega T.
yes, and then we can figure out our PXX as well.
Cody says, so I spent all this time memorizing the general solution just to not immediately use it. It's kind of fun to like derive things sometimes.
Yeah, pretty much. If
Things
anything,
change.
you should memorize like the D'Alembert and some of the like bigger, like really ugly integral solutions because you'll use those.
Mhm. But this one's like
your,
simple enough that you can
Your
do it.
x plus CT and your x minus CT, you don't really use that much. It's more of a conceptual understanding that your solution is a superposition of a forward and backward traveling wave.
Mm-hmm. Right. Yeah. Forward and backwards waves. Okay. Okay. So then PXX. Well, now this depends on X, right? So now this is X of X. There's so many X's.
Yeah, or in this case, now you could just use prime notation.
Okay. So we can X. We
Since we're
can
in
just say X
essence
double
putting
prime.
it into ODEs, yeah.
Okay. Cool with that. All right. And then do I slam this back into the wave equation?
Yeah. Yeah, you plug that back in.
So let me plug it back in. So PXX, so you get X double prime of X sine omega T is equal to negative omega squared over C squared. X of X sine omega T. These cancel, right? Okay. And then, yeah, this is... So X of X is equal to... isn't this just sine omega? Well, I gotta remember how this works. This is like the simple harmonic
yeah, so-
oscillator.
Yeah, we did one just like this earlier. So you just move your right hand side over. So you would get X double prime of X
Yeah.
minus omega, or yeah, plus omega squared over C squared X of X
Equal to 0.
equals 0. and then we can solve what's called our auxiliary equation.
Okay.
And you would get roots at
-1 and 1, right?
No, it would be i's.
Oh, sorry, plus or minus
Omega
I,
over
right?
C times I, and negative omega over C times I. And that, whenever you see an I in there, you just plug it into your
Sine and cosine.
like the general. Yeah, it just becomes a cosine of kx plus b sine of kx.
Where k is equal to omega over c?
Yeah.
Yeah. Okay. Yes. Okay. Yeah, because what happens here is we say, like, I'm going to say, like, x of x is just equal to e to the ax, whatever. So x double prime is equal to a squared, e to the ax. So then I have a squared plus omega squared over c squared is equal to 0. So then a is equal to plus or minus I omega over c. We move that over, take the square root. So then you get e to the plus or minus I omega over c. But then this is the same thing as sine omega over cx plus cosine omega over cx.
Yeah. And this is kind of a tangent, not entirely relevant to this, but a little fun fact about that auxiliary equation is the solutions to that equation are actually the eigenvalues to your solution.
Oh, okay.
Technically, yeah.
Cody, does this make
Remember,
sense
like-
how we got to here, Cody? Did you need me to explain it like this? Yes, Ricky, don't worry, I won't forget. Yeah, it does. Okay, cool. All right, cool. So you solve the auxiliary, right? And so we get x of x is now equal to this. Okay. And there are
with
constants.
constants.
And there are constants,
Yes,
right?
yes.
There's a C1 here, there's a
Mhm.
C2 here.
Yes.
Okay. And then do I have that just multiplied by sine omega t? Because that's what my T of t was.
Yeah, but for now, it'd probably. Well, yeah.
Oh,
you would
but wait,
multiply
we also have
by
to
your-
solve the boundary conditions though, right? Do we have to solve this
if
one?
you would use your boundary conditions to figure
Okay.
out what these specific values are.
Okay, so by boundary, right? X of A has to be equal to 0, right?
Mhm.
That's what we said. Yeah.
And then our P of 0 comma t has to be equal to P omega sine of t as well.
Okay, so if X of A is equal to 0, this would already go to 0, so that means C2 has to equal 0. Yeah?
I believe so.
Because if this is 0, this would become 1. Cosine of 0 is 1, right? And then x of 0 comma t needs to be equal to x 0 t and then wait, what did we say? Oh, okay. We said, okay, so P of 0 of t. So P 0 of t needed to equal P naught sine
I
omega
see.
t.
But I don't think our C2 is 0.
You don't think it's 0?
Because
Okay, why
we-
not?
Yeah, so we have to consider when we multiply in our sine of omega. Our sine of omega t.
Oh, okay. Okay,
Yeah,
so
because
maybe
x of x is just part of the solution.
Yeah, okay, so
right?
let's
But,
okay, so
we're
let's write the
figuring
full
out
thing
our
then.
P.
Right? So P of x comma t is equal to x of x times t of t, right?
Mhm.
We've already assumed that t of t is sine omega t, right?
Yes.
Okay. And then x of x, do we have the p naught over x naught still there?
It'll get brought into the constants when we evaluate the constants with our boundary conditions. So we can just write C1 and C2 plus.
Okay, so this is
how
going to be
we have-
c1 sine omega over c times x plus c2 cosine omega over c times x. But then I'm multiplying by this as well, right? So then I have sines.
Mhm.
I have like combinations. So I have c1 sine omega over cx sine omega t plus c2 cosine omega over cx sine omega t.
Mhm.
Okay. And then I know that P of A comma T, P of A comma T I think just has to equal 0, right? For
Mhm.
all time, right? The pressure fluctuation is always 0. Okay. So, when x equals A, you get C1 sine omega over CA.
It should be. I think it should be P prime of A comma T. I didn't read that. 'Cause
Interesting.
It's saying that the pressure fluctuation at this point.
Oh,
has to
okay,
be
okay, okay,
0,
okay, okay.
Not
Okay,
that
I
the
see.
pressure itself is 0.
Okay, so this is P of T. Or dP dt,
Yeah,
right?
It should be. Yeah. It should
Partial
be
P, partial T, whatever. Okay. Yeah, okay. So, partial P, partial T of A of T has to equal to 0. Okay, so then the derivative of this with respect to T, C1 sine omega over Cx cosine, and then there's another omega here, sorry, right? Which I guess doesn't matter, because we're just going to like try to make things like 0 or not. Okay. And then this is cosine omega t minus C2 omega. Okay, and sorry, this is at A. Cosine omega over CA sine omega t. Or cosine omega t.
Mhm. And if we want, we could
What's
first. It
the
might be a
positive
bit easier if we evaluate our P of 0 comma T instead.
Oh, okay.
Because that makes
Is equal to P naught sine omega t, right?
yeah. And
Okay.
because we have our cosines and our sines, one of them will
This will go
cancel
away.
out.
Disqualified.
Right, okay. This will turn to 1. So this is equal to C2 sine omega t. So that tells me C2 is equal to P naught.
Mhm.
Night, Reki. Okay. C2 is equal to P naught. Cool. So then when I get here, in order for this to equal 0, I see. Okay, wait. Okay, so. Okay. Like, this has to equal the negative of this, basically.
Mhm.
Okay, so by this, I'm going to say that C2, or I didn't know C2, so I can cancel the omegas too. Okay, so rho naught cosine omega over CA cosine omega t equals negative C1. I already canceled the omegas. Sine omega over CA cosine omega t. You can also cancel these, yeah. Okay. So then C1 is equal to negative rho naught cotangent of omega over CA. If I move that over?
Yeah, that looks correct.
Wow. Okay, cool. So, putting it all together. We had this whole thing. All right, let's pull it down. See, so this is so funny. Okay, so negative P naught cotangent omega over C times A times sine omega C over X times sine omega T plus, and then C2 is just P naught.
Mm-hmm.
And then this is P of XT. Yeah?
Yeah, I believe so. I think that looks good.
Wow. Okay, but we're not done though. Sorry, there's a part C. I got really excited. I was like, oh man. Does that make sense, Cody? What we went through there? And now I see it, right? I see how x of x is a function of P naught, right? There is like a P naught in there.
Yeah. And and part of it is we just said kind of like how when you solve like your normal differential equation and you get like your e to the c or whatever, we're just like, yeah, let's call it another constant c.
Mm-hmm.
It's kind of the same thing here. We're like, well, x of 0 is a constant.
Yeah.
Our p naught over, I forget what it was, like p naught over something, is also a constant.
P naught over x naught is also a constant.
P naught over x naught is also a constant.
So we just assume that t is sine omega t.
Into each other.
I see. And then that's just going to fuck up the C1 and the C2 anyways. Later.
Yeah, and it's just going to change how we have to evaluate that. But it doesn't make too much of a difference in difficulty to do it that way.
That's so cool. Okay. I like it. It's just like assume and then just hope it works out, and it does. Describe how the relative intensities of the modal vibrations may vary with frequency. Is that like the C1 and C2 stuff?
I believe so.
Yeah, I feel like this is the amplitude, I guess, right?
Yeah.
Yeah, these are the amplitudes. Okay. I don't know what that really looks like, but I guess it, functions.
Actually, I think the amplitude is not including the x part. I don't think.
Okay. Yeah, so it's just this one?
If I remember correctly, there's some trig identity. I remember doing something like it in PDE last semester where you can combine the cosine and the sine to get like a one trig function, subtracting the values and adding them. I just don't remember exactly what the property is. Okay.
Oh, it's funny. My timer's like, you have to go tutor another kid. I actually don't think I'm tutoring this student right now, though. Ruru is her name. She's great. Okay. So I think we answered it, no?
Yeah. Yeah, that's a correct solution.
That is a correct solution. Hooray! Okay, cool, Cody. That was cool. I really appreciate Breasticles, working through this with me. Man, dude, yeah. I've never taken PDE.
It's a pretty fun course. I recommend it.
Yeah. Maybe I'll go back to school. Just kidding. Just fucking kidding. Oh, Danska Krona from DK. Oh, from Denmark, I guess. I hate trying to remember all the special trig functions. They're so cool, though.
Good job.
Yeah, the trig functions aren't that bad. I think it's all the... And that's actually what enables me to learn it. Not too terribly, I hope, and, not to frustrate people teaching me, is that I at least understand all the underlying foundational stuff. It's not too bad. So you're not having to, reteach everything. It's just okay, now you know all these tools, so here's how you put the tools together. Okay, Cody Beckett. Yeah, there you go. Cosine x, sine y. Yeah, it can be written as like sine y plus x, sine y minus x over 2. Yeah, that's one of the identities. Nice. Okay, well, Cody, we'll put this solution here also in our Discord, so you can go see. Here's the whole thing, and then there's also the link for it if you want to go check it out. Are sinusoidal derivatives hard? No. Sine and cosine are pretty chill, man. I would say the trig integrals start to get complicated, but the derivatives are super simple. Okay, I do have to go because I'm kind of like out of time here at this point. But let me see what the other questions were. The inequalities. Yeah, this. Oh dear.
Oh no.
This would take me time to do. I like this pineapple. I would do this next time. You're very welcome, Cody. Ooh, this is cool. Triple integrals. Oh, I do like that. I don't know what this is. Sorry. Is this just a density? Isn't this just 4/3 pi r cubed? I think this is just 4/3 pi r cubed times density. And then DM Screator had a lot of stuff. Okay. Let me do this. Submit these questions. Well, here, I'll put them in the Discord, but if you want to like resubmit them for tomorrow, I'll do them. I'm a little bit over time. But okay, cool. All right, let's close out the stream. All right, thank you everyone for coming to Actual Education Office Hours. Yeah, good questions today. Big ups to Breasticles for teaching me PDEs today. Thanks, man.
You're very welcome.
Yeah, this is super fucking cool. Okay, our next stream, don't worry, it's going to be tomorrow. So if you go to the website, actualofficehours.com, you'll see a link here for our streaming schedule. Go click on that, and you can see all the times that we stream. So we have another stream tomorrow. Yeah, it's okay. It's okay, Blue. Come by tomorrow. I'll help you out with the stats stuff. I love that stuff. So tomorrow we'll have a stream. It's after Zach's stream. He's another great person. Did I shout out Zach? It won't let you submit the exact same screenshot, so maybe take a screenshot of the screenshot. But yeah, let me make sure I shout out Zach. I don't know if I shouted you out today, Zach, already. But yeah, Zach's gonna be streaming tomorrow. And then yeah, if you found us through any of the other platforms, make sure to go follow us on Twitch, because that's an awesome platform that we can go use to go raid and say hi to other people. Let's see who we're gonna go say hi to today. Let's go raid someone. Bum, 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 bum. Dun, dun, dun. This looks. What is this person doing? This kind of looks like. This looks like math. I think it's math in like another language. I think it's like Brazilian or something. Portuguese. Oh, someone's computing pi. Yeah, go check out this person computing pi. Monday Night Math. Okay, cool.
Good job.
All right, go say hi to Justin. He's a cool professor. I forget what university he's at. I want to say it's Oxford, maybe, or maybe another one. Who would have known someone named Breasticles would be so smart? The internet's a beautiful place, man. You
Never know.
You never know. Don't judge a book by its cover.
Oh no.
Don't do it. Tough name. Okay, cool. All right, well, enjoy the start of your week. We will see you tomorrow. Peace.